Good morning and a heartfelt welcome to each and every one of you as we commence the third and final day of the fourth International Conference on Recent Trends in Advanced Sciences and Computing, ICRT-ASE 2025. This successful three-day conference has been organized by the School of Advanced Sciences and Languages at VIT Bhopal University in close collaboration with the Indian Institute of Technology, Indore. We once again extend our sincere gratitude for the generous support of our sponsors, the Anusada National Research Foundation, the Council of Scientific and Industrial Research, and our indexing partners, Scopus and Web of Science, whose contributions have been vital to the conference's success. For the past 2 days, this conference has truly served as a dynamic crucible for innovation, successfully bridging the gap between cutting-edge scientific research and transformative computational technologies. Today, as brilliant minds converge one last time, let us focus on synthesizing the groundbreaking insights, solidifying the collaborative partnerships we forged, and charting the practical future course of interdisciplinary discoveries shared on a remarkable platform. We are honored to be joined today by such distinguished visionaries and leaders in science and technology. Their presence profoundly elevates the significance of this occasion. We are now commencing our plenary sessions. These sessions provide high-level vision, set the intellectual tone, and inspire discussion for the rest of the program. Now, as we prepare for this highly anticipated plenary session, which truly set the intellectual benchmark for the day, it is my honor to introduce the distinguished academics who will be expertly chairing this session. We are privileged to have Dr. Shafiq Ahmed to have his guidance and expertise on this day. With that, I hand over the proceedings to our esteemed session chair to commence the plenary session. Please give a warm welcome to Dr. Shafiq Ahmed.
Beta, about her. You are reading. तो करो ना बेटा पहले.
We have the honor of introducing Professor Yeliz Carasa from the University of Massachusetts, USA. Professor Carasa is a senior research professor in neurology and a leading scholar in applied mathematics. Her research focuses on complex system sciences, advanced computational methods, AI applications, and mathematical neuroscience and biology, with a deep specialization in solving advanced mathematical challenges for medical and engineering applications. Today, Professor Carasa will present her work titled Mobile Cloud Computing and Knowledge-Based Neurological Healthcare Systems, Hidden Markov Fractal Fractional Calculus, and AI for Precision Medicine. Please join me in extending a very warm welcome to Professor Yeliz Carasa.
Thank you very much for your kind introduction, and I'm just starting my slides.
Hello, welcome.
Hello. Hello, everyone.
I am missing you very much. You should be here offline.
Thank you very much. I wish I were there with you all, but I hope I will be able to make it for the next time. Dear and esteemed professors, colleagues, as well as participants, first of all, I greet you all with respect. As has been introduced, I am Yeliz Karaca from University of Massachusetts Chan Medical School, and I am pleased and honored to have been invited to the 4th International Conference on Recent Trends in Advanced Sciences and Computing, organized by the School of Advanced Sciences Languages of VIT Bhopal University in association with Indian Institute of Technology, Indore. Before I start my presentation, I would like to convey my thanks to the management faculty, staff, and students of VIT Bhopal University, the founder, the chancellor of the university, the chairman of the conference, Professor Hemant Kumar Nashin, and organizing secretaries Dr. Mamta Agrawal and Professor Shafiq Ahmed, and also conveners, co-conveners, members of the organizing committee, fellow academicians, researchers, faculty members, and the brilliant student participants, as well as volunteers, and everyone actually who has put in their efforts in realizing this academic event. And let me say that India holds a special place for me, and for many years we have been with honor and pleasure involved in such academic events and lectures. So as you have introduced kindly, my lecture is entitled Mobile Cloud Computing and Knowledge-Based Biological Healthcare Systems, Hidden Markov Fractal Fractional Calculus, and AI for Precision Medicine. And this is the layout of my presentation I will be delivering today. First of all, let me say a few words about the significance of mathematical modeling and precision medicine. Numerous natural phenomena display repeating self-similar patterns. And this is a case applying to the brain, which is equipped with a complex structure. And the estimate of topological complexities of an object should be taken into account in our analysis. And in domains of neuroscience and mathematical neuroscience, we see the prevalence of complex entities regarding the brain, which requires different levels of medical data analysis and observation. And when we look at precision medicine, actually, we can see that the definition of precision medicine is defined as an emerging approach for disease treatment and prevention, considering individual variability in genes, environment, and lifestyle for each person in question. So precision medicine takes into account different qualities and different features of patients. And this is what I pay particular attention in my studies. So when we have precision medicine approach, it can enable doctors as well as researchers to predict more accurately which treatment and which prevention strategies for a specific disease will work in which groups of people at individual level. So we have a general saying, we don't only evaluate the disease only. What matters is the patient and the patient's qualities, as I have just mentioned. Okay, and when we look at mathematical models, there are different means in mathematical models, including differential equations, fractal-based analysis, fractional calculus, and so on. In these frameworks, artificial intelligence techniques allow us to do a number of applications, including the prediction of mechanisms, ranging extensively from living organisms to other interactions along incredible spectra. So various aspects of artificial intelligence and the convergence of these models can enhance expertise in numerous domains, including data science, machine learning, natural language processing, namely NLP, computer vision, virtual integrations, cloud computing, and deep learning. As we know, human diseases are very complex and they can change significantly from one individual to another. So the aim in my studies has always been to work towards tailoring and customizing medical treatments so that it can be better served for individual patients. And in mathematical models, there are uncertain phenomena we see which are important for description and computation of complex dynamical behaviors like human diseases. And in this presentation, actually, we will be looking at some of my studies, particularly addressing these concerns. I have already talked about the mathematical modeling and the role of artificial intelligence. So, and also there is the quantum and quantum machine learning we can mention here as one of the advanced technologies. And they are very important tools owing to their capability of quantum algorithms, which are equipped with the unique characteristic of quantum computing. So overall speaking, actually, quantum supremacy provides the benefit owing to the capability of solving a problem, which is not possible to be solved through classical computers within a reasonable period of time. And a relevant benefit is related to the fast estimation and time saving, because the time elapses, and this elapsed time can be reduced for different data sets at hand. Okay. So after mentioning the convergence of AI, mathematical modeling, and quantum computing, we can also have a look at computational complexity, which I work in my studies. As you can kindly see the definition, computational complexity refers to the amount of computing resources which are needed for particular types of tasks. And computational complexity theory allows the evaluation of resources required for a class or category of a peculiar task for the classification to be made at different levels of complexity. Here, we consider these factors to attain
Excuse me, Alice. Your slide is not moving. Can you please check?
Yes, it is important to attain the efficiency of information processing while attempting to understand the human brain. So computational complexity is significant for analysis as problems increase in size and get more complex, selecting functions and algorithms for efficiency and solvability. So purposes depend on classification and modeling based on the level of complexity concerned. So we can see the connection between these points.
Visible.
When we have
Alice, can you
yes,
hear me?
please.
Yeah,
Yes, I can hear
your
you.
slides are not moving. Could you please check?
Okay, okay. I share the screen actually, but let me check once again.
Yeah, please go ahead.
Now, can you see?
No. But here.
Slide is not.
Yes. Can you
Yeah.
see further points? Yes.
Make it full slide.
Okay.
Power presentation. Yeah.
Is it okay now? Can you see? These are the parts I have already.
Yeah.
Okay. So there's no problem. Thank you for warning. So I have already talked about the convergence of AI, mathematical modeling, and computational complexity. Here, it is important that the quantification of resources is done, and this quantification of resources requires to solve computational problems, actually. And here, computational complexity refers to the measure of the amount related to computing resources, for example, time and space, considering what a particular algorithm consumes when it runs. So it is possible to conduct the analysis over the runtime with the related sort of data determined and employed along with the methods. Okay, now if we have a look at the studies I have already done, which I will share at the end of my presentation, you can refer to the references for further points. I'm going to move more quickly for the first studies, but I will focus more on my study concerning mobile computing, which is also the title of my presentation. In this study, whose name is Fractal and Multifractional Based Predictive Optimization Model for Stroke Subtypes Classification, we did the classification and developed a fractal multifractional based predictive optimization model for the classification of stroke subtypes. Here, it is important that to note that some details are not always detected by physicians. So the aim of my work has been to identify the significant self-similar and efficient attributes to achieve high classification accuracy rates for stroke subtypes. And for this, I have followed two approaches. One is the application of fractal multifractal methods on the stroke data set. And here you can see the steps, the application of box counting, dimension, and wavelet transfer modulus maxima. And the second approach included the application of feed-forward back propagation for stroke subtype classification with these steps, applying the algorithm on the stroke data set, both of them, the original raw one and the generated one, and comparative analysis based on accuracy, sensitivity, and specificity for the data sets, which is also very important for precision medicine, which I have already mentioned. So I skip these slides because they involve the methodology. Here you can see figure 1, which is an MRI for an ischemic stroke case. And after the approaches, I have just mentioned, we applied, we achieved accurate results, and it has been a good application of box counting methods and other methods. Here I skip because I was
Excuse me. Your slide is not running still because your figure is not visible here. Could you please check?
Can you see the slide?
Can you tell the slide number?
Yes, here it is 2.4.1. I skip these slides so that I am going to focus more on my further studies, okay?
No, there is no change in the slides.
So I am going to share once again.
There was problem yesterday as well. Could you edit?
Yes, I am sharing.
Could you please do one thing? Can you send your slide? We'll be doing from this side, and you can tell the
Maybe
next.
you will be able to see now. Can you see now?
Yeah, we can see this.
Okay.
Yeah, now it is the picture. No, it's gone. Now it's okay. Yeah.
Okay, so the next study is fractional calculus operators with Bloch-Torre partial differential equation, artificial neural networks, computational complexity modeling of the microstructural brain tissues with diffusion MRI signal processing and neuronal multi components. And in this study, we used the MRI, and the established model of the study used also fractional calculus operators and Bloch-Torre partial differential equations. These slides show the denotations of the equations we used in the study. And this figure shows the neurological configuration of the data-centric human brain with artificial neuron interconnections from inputs with white matter, soma and dendrites to outputs at axon terminals and bundles. Okay, as for the experimental results in this study where a feed-forward neural network with BFGS quasi-Newton equation was used, which is one of the ANN, artificial neural network algorithms. We use this for its speed and reliability as it is a rapidly trained algorithm and an applicable method to train moderate size feed-forward neural networks. So we have used these. Following these materials and methods, we may move to the experimental results and discussion. Based on the computational and medical aims, our study has followed the application-related steps. And spin doctor as the MATLAB tool was applied to the brain neuron spin unit dataset. And a high-performance neuron mesh generator over a randomly selected 6 realistic cellular meshes of neuron was developed. And thirdly, a numerical computing model based on finite elements method for the multi-compartment BTPDE with Caputo FOD-based 3-parametric Mittag-Leffler function has been formulated and implemented through extension. Okay. Following these explanations, you can see table 5, which shows the application results of artificial neural network computing we followed in our study. Okay, as for our next study, which was on another neurological disorder, namely multiple sclerosis, the advanced mathematical models and how they can be integrated into technology has been shown in the study so that it can be possible to facilitate and manage critical decision-making processes which have crucial roles in human life and also on human life quality. So this study has adopted a novel integrated approach with multiple stages and multi-source complex spatial data. And I applied 2 approaches in the study. One is the hidden Markov modeling, to obtain for diagnosis and prediction of future course of multiple sclerosis subgroups. And the second approach we followed is the multifractal Bayesian method for the elimination of irregularities. And this is the layout of the study. As I have kindly mentioned, you can refer to my studies for further details. As we have limited time, I just mentioned the highlights and important parts, the gist of the studies. This study shows the importance of precision medicine again, which I have tried to explain in the beginning of my presentation. And it involves many parameters in detail, including the profound understanding of genetics, environment, and lifestyle of a person. And multiple sclerosis patients experience a variety of different neurological symptoms, and the severity of the disease changes from mild to severe. And the biological underpinnings of these phenotypes need to be explained and clarified. So precision medicine involves the classification of these subtypes based on the underlying biology rather than clinical phenotypes alone. So this is important for the disease course and treatment response. So here we used VIT algorithm as well, and we made use of its recursive and iterative application to enable maximation, and it uncovers the most probable hidden state sequences. And here we used 8 observation matrices to understand the state transitions. These are the equations I have used. And this table 3, shows the procedures of the hidden Markov application vis-a-vis for the MS dataset and the generated MFM-MS dataset. And here you can see an example observation matrix, which was 8 in number in this study. Here we show the importance of classification and precision medicine with some important problematic situations evaluation in complex systems. It is important that prediction, diagnosis, and prognosis are understood to play a critical role for managing the process efficiently to maintain the life quality of the patients and also to facilitate doctors. Now here, this is the study I would like to focus more in this presentation today. I'm delivering. The name of the study is Mobile Computing Based Stroke Healthcare System. And the main theme of the presentation actually shows the importance of technological integration in medical context with mathematical models established. And let me say that information technology has recently seen an important progress in innovative healthcare technologies that rendered healthcare data bigger. And connectivity on 7 days, 24 hours basis was taken as the core point of the study. And this connectivity involves human to device and device to device connection, which is crucial in individuals' lives. So we established a mobile cloud system in the study, and parallel with the rapid developments of the Internet of Things, IoT, this convergence has become an important issue. And our proposed method can be converged with mobile cloud environments with cloud computing in handling healthcare information. So in this study, as you can see as the last slide, the last bullet point, we used virtual dedicated server and 4 vCPU and 8 GB RAM, and we proposed a model based on Android-based mobile phones for stroke patients with cardioembolic and cryptogenic subtypes. And the system setup through the study has 2 basic application elements, which are the mobile application and server application. An artificial neural network module is beneficial for classifying the 2 stroke subtypes, while server application is used for saving the data from patients. As I have mentioned here, connectivity is important. And table 3 shows the steps for the formation and implementation of this proposed and developed mobile cloud computing-based stroke healthcare system. The first step involves the implementation of the artificial neural network model on virtual dedicated server. Step 2 involves the mobile application for the client and server. Step 3 is about using stored patient information for A&N training. And the last step, step 4, identifies the subtype and tracks based on the server client. And this figure, which you may kindly see, shows the interaction flow related to the stroke diagnosis healthcare system for setting the problem that arises. So we suggest the solution as stroke diagnosis healthcare system, and the system allows the patient to conduct the control of his or her own illness. In this way, the patient becomes more aware of his or her health status and can direct and guide himself or herself toward preserving their life quality. Accordingly, figure 4 shows this case model as a use of stroke diagnosis healthcare system as an alternative scenario and central scenario with the prerequisites. The primary actor, prerequisites, critical central scenario, and alternative scenario are shown in this picture, as you can see. And the next slide, table 4, shows the MLP algorithm in stroke diagnosis healthcare system accuracy. And we can say that this stroke diagnosis healthcare system has been tested and the accuracy rate has been achieved as high as 85%. And the test phase of the stroke diagnosis healthcare system, the procedure as to deciding the stroke subtype, whether it is cardioembolic or cryptogenic, is to be continued through the run command. And finally, this slide shows the model based on the Android-based mobile phones. We have already mentioned the basic application steps. Here, what is important is that the outcomes will display an individual will have a unique understanding framework. The outcomes will be utilized for distinguished proof of stroke-related data. And here, a user-friendly and efficient system for stroke determination has been established through the integration of mathematical modeling and AI. Here we see the importance of convergence here about information technology and digitalization. Okay, these remarks bring me to the end of my presentation, and here you can kindly see all the references I have tried to address in my presentation. On this occasion, I would like to thank you all for your kind invitation and kind attention. I hope to see you in the future academic events. Thank you very much. Kind regards.
Thank you very much, Delis. It's a wonderful talk. And if you have any questions, audience, please, door is open for questions.
Hello. Hello, Kasha. Hello. Hello, Kasha.
Is the sound system is not very well? I cannot hear you very well. Could you please send your questions to my email address, which I am showing now? I will be happy to answer your questions.
Now I available. Okay.
I also typed my email address in the chat box. Please ask your questions there. I will be able to respond better because I cannot hear the auditorium very well. Sorry.
Now his voice is clear to you. Hello. Hello. I think it's good.
Thank you, Dr. Shafiq sir, for sharing this session. Thank you, Professor Yanis Karasa. Your work at the intersection of advanced computing, fractal calculus, and precision medicine is not only groundbreaking, but provides a crucial roadmap for the future of neurological healthcare. We now have the distinct pleasure of proceeding with the next keynote lecture. It is my honor to introduce Professor Manoj Kumar Patel from the National Institute of Technology, Nagaland. Professor Patel is a distinguished academic in the Department of Mathematics. His research explores core areas of algebra with a specific focus on structure of nomenclative rings and modules. Further, his work bridges theory and application with active research in algebraic coding theory and graph theory. Today, Professor Patel's presentation is entitled Current Perspectives on Chain Conditions in Modules and Rings. I would like to welcome Professor Sharif Ali as the session chair for this session. Please join me in giving a very warm welcome to Professor Manoj Kumar Patel for his keynote address.
From there? Sir, 5 minutes sufficient है आपको?
Thank you very much to the organizer and especially to the Professor Adnan. Yeah. Yeah, thank you very much to the organizer, especially to the Professor Adnan and Professor Mumta for inviting me and for nice hospitality inside the campus and outside. And I am thankful to the organizing team for providing me the opportunity to speak about the current perspective on the chain condition in modules and rings. So here we have to talk about the ascending and descending chain. These are the outlines, and our objective of the talk is here. We have to discuss about the ascending and descending chain condition in the modules and rings, where we have to explore the properties of the well-known structure Nathaniel and Artinian rings and modules, and their generalizations in various contexts. Most probably we have to focus here in the well-known theorems, Hopkins-Levitsky theorem, and dual of the Hilbert basis theorem. Next, we have to investigate here Hopkins-Levitsky theorem is holds for the rings structure. So we have to try to explore the possibilities this condition is holds for module or not. So unfortunately, Hopkins-Levitsky theorem is not holds for the case of the modules. But this structure is going to be extended for the large structure of the semi-projective modules, which we have to discuss here. And next here, some preliminary things we have to discuss. Most probably these are the familiar with you. So here projective modules. So before projective module, we have to define the free module. Free module is the just a structure of the modules which have the basis element. For example, we can say that every vector space. Every vector space has the basis over the field. So, and our modules is the structure over the ring. So this is the just generalization of the vector spaces. So every vector spaces is considered as the free modules. So projective module is the summand of the free modules. We can, oh, sorry, please here. Yeah. So thank you. So here we have to discuss N is the module is said to be the projective module if it is the direct summand of some free module. Means there exists some complement here whose direct sum with N is going to be free module. Then we have to call N is the projective module. In other sense, we can define here suppose M is the NER module and X is the submodule of M and phi is the projection from M to X. If any R homomorphism F from the module N to X is can be lifted to an R homomorphism G from N to M, then we call and this diagram is commutes. Then we call N is the M projective module. Means here just like here pi composition G is coming F. Means here F is factored with the help of the G. Then we call M is the M projective. And if M is itself M, means M is M. So M is called M projective means M is quasi-projective module. For example, we can consider here N is equal to 0 bar, 2 bar, 4 bar as a subset of the Z6. So this is N is the projective R module over the Z6 because here N direct sum N is coming Z6 where N is 0 bar and 3 bar. And another example we can consider A is the commutative Northern ring. Then we construct the ring R like A class A. Then M we have to take like 0 class A. So this is the projective R module because this is the R over itself is the free, and M is the 0 class A is the direct summand of A class A. So next angle is the dual of this projective R module is the injective. So we call here N is the injective M injective module. If any injective maps I from X to M and every R homomorphism F from X to M can be extended from M to M such that this diagram is commutes. So for example, we can consider here every module over division ring is injective and every vector space is the injective R module. And next example is modulo every modulo over semi-simple rings are the injective, and we have to consider any field of fraction of any ring which is divisible, and this divisible module is going to be the injective modules. So next things is here we have to come to our topic here, chain conditioning modules. So chain conditioning module is discussed here. This is the descending chain condition. So if this descending chain condition of the submodule is terminates after finite number of steps, then we call this is the Artinian. But here we have to take the only focus on the essential submodules. Essential submodules means any submodule is said to be essential if it has non-zero intersection with other non-zero submodules. So just like for example, we have to consider any submodule of the set of integer over itself is the essential submodule. And here we are focusing the descending chain condition of the essential submodules. If this is going to be terminates after finite number of steps, then we call essential Artinian or E-Artinian module. For example, here we have to consider Z81. So this is the essential descending chain condition of Z81 is going to be terminated at 27 times Z81. So this is the example of the essential R module. So for proving the result, we have to use this lemma. Here M is the any finitely generated E-Artinian R module, and if M can be expressed as M direct sum P, where P is the any R module, then P must be going to be Northern R module. And with the help of this lemma, we can state the important result is here. Every R module M is E-Artinian if and only M modulo Stokes M is E-Artinian. Here Stokes M is the sum of the simple submodules, or we can say that the intersection of essential submodules of M. So with the help of this lemma, we can prove this result, and in continuation we find here if M is E-Artinian R module satisfying the descending chain condition on cyclic non-summand, then Jacobson radical JR is acts T nilpotently on R. Yeah. Here, J of Jacobson radical means intersection of all the maximal ideals, and T nilpotent ideal means any ideal is said to be T nilpotent if we consider the ascending chains. Means x1, x2, xn is the element of the ideal. So if there is the ascending times x1 times x2 times xn is going to be 0. Means there is exists some ascending sequence like that one is going to be 0 at n steps. So we call T nilpotent. Now, sorry. Okay. So next result, here we have to define local module. A module is said to be local if the sum of all its proper submodule is the proper, and module is called W local if it has unique maximal submodule. So by definition, every local is W local, but converse is not true. And next, we have to suppose here PM denotes the sum of all radical submodule. Radical submodule is defined like radical of K is equal to K for each submodule K of M. So if PM denotes the sum of all radical submodules of M, then we define module M is said to be reduced if PM is going to be 0, means sum of all radical is going to be 0. For example, we consider the Z module like ZP, which is the structure all the rationals of A by B type, where P does not divide B. Then this is the example of W local as well as reduced, but this is not a local. So we have to discuss under what condition W local R module is going to be the local. So in this case, we have the partial proof of that one. So with the help of this lemma, let M1 and M2 be the submodules of an R module M. And if M is the maximal submodule of M1, then either N plus M2 is equal to M1 plus M2, or N plus M2 is the maximal submodule of M1 plus M2. So with the help of this, we find the partial proof of the converse part of this. Yeah. So we have to state like M be any non-zero W local E Artinian R module. If M is reduced, then M is local module of finite length with respect to the essential submodules only, not all submodules. So next result on the chain condition in rings. So we have to define the chain condition of rings. We just like the descending chain condition of the essential ideals is going to be terminated, or we call ring R is E Artinian if it is forms an E Artinian modules over itself. So next definition, ideal B of R is semi-prime if A square is contained in B, or A to power some index A to power n is contained in B, implies A is contained in B. So for example of the semi-prime ideals, we can take any square free and product of the distinct primes is the taking n. So ideal generated by n in Z is the semi-prime. And next here we call a ring semi-prime if 0 is the only semi-prime ideal. So semi-prime ring is the example. We can consider the semi-primitive ring which Jacobson radical is 0. That will be the semi-prime ring. And a ring R is said to be Goldie if it is of finite uniform dimension and satisfies the ascending chain condition in the annihilators. So next, an ideal J of a ring R is called nil if every element of the ideal is J nilpotent. So here with the help of, and for example here Goldie ring, so every Nathaniel ring is the Goldie, but converse is not necessary. So we discuss here any semi-prime E Artinian ring R is Goldie ring, but converse is not true. Is here. And with the help of this, we find the result here. R is the semi-prime E Artinian ring. Then cosine R modulo P is the Goldie ring for every simple prime ideal P of R. Means we can associate with these two lemmas. So we can say that cosine of the Goldie ring is Goldie if here P is the prime. Means cosine is taken with the respect of the prime ideals only. So in the continuation of this, next result is here. R be E Artinian ring, then R is semi-prime ring. If and only R has no infinite set of orthogonal idempotent. So here semi-primary ring R is said to be semi-primary if R modulo JR is the semi-simple and JR is going to be 0, T nilpotent, not 0, T nilpotent. And next here result based on this, ring R is E-Artinian ring satisfy the descending chain condition on cyclic non-Samand ideal, then R is semi-regular ring such that JR is T nilpotent. So semi-regular can be defined like ring R is semi-regular if R modulo JR is regular and JR is means idempotent of the R can be lifted to modulo JR. Then we call R is semi-regular ring. For example, we can say that any semi-simple ring is the semi-regular and local ring is also is going to be semi-regular if JR is the maximal idea and factor ring of R is going to be the division rings. So in that case, local ring is the semi-regular. And here ring R is E-Northern if and only if any direct sum of injective R module is injective. This is the well-known result. Here just a simple extension. We have to verify this one is result is hold in case of the ascending chain condition of the essential submodules. Ideas only. So with the help of this lemma, we can state the important result is here. R is E-Artinian if and only if the injective R module is direct sum of family of injective envelopes of simple modules. So here injective envelope of any module is the smallest injective module containing that module or largest essential extension of the module is called injective envelope. So here dual of Hilbert basis theorem, we know the Hilbert basis theorem is if R is Northern ring, then polynomial ring over R is also Northern. But their dual is not true in case of the Artinian ring, but their extension means just like E-Artinian ring. This result is holds. So here we have to state if R is E-Artinian ring, then polynomial ring over R is also E-Artinian. So this is the dual of the Hilbert basis theorem. And next we have to discuss about the semi-projective modules. So before defining semi-projective module, we define the M cyclic submodule. So any submodule M of M is M cyclic if it is isomorphic to M modulo L. Here L is the sum submodule of M. Or we can say that M is M cyclic if it is homomorphic image of some endomorphism of M, like this one. M is going to be sub image of M, means M is the endomorphism of M. So M is isomorphic to F of M, something we call. So we define here R module N is called M principally projective if any R homomorphism F from N to M cyclic submodule SM of M can be lifted to any R homomorphism G from N to M such that this diagram is commutes. Means F is factored by G. So we call N is M principally projective. Okay. So and we call here an R module N is M principally projective, then we call M is semi-projective or M is quasi-principally projective. So in this case, we have to, for example, of this, so several examples we have to collect it here. So set of integer and Z5 means Z modulo 5, Z residue class of integer modulo 5, residue class of integer modulo 6. All are the example of the semi-projective module over the set of integer. So by the definition, clearly we can observe that projective and quasi-projective module are the particular case of the semi-projective. Means semi-projective is the simple generalization of these two structures, but converse is not necessarily true. So counter example of this part 2 is here. We can consider Q. Set of rational number is the semi-projective but not quasi-projective over set of integer. And next we construct the example here. Suppose F is the quotient field of a ring R, then and R is considered as integral domain is here. Then we construct the structure M is equal to F direct sum R, then this would be the semi-projective. But this is not a quasi-projective module. And any prime P, the proof of P group ZP infinitive is not a semi-projective module. And the next example is here, we consider ZP and ZP square. Both are the quasi-projective or semi-projective module, but not necessarily M1 is M2 principally or M2 is M1 principally projective. So this is the counter example we have taken. Now we have to discuss here perfect ring and their extension characterization with the help of the semi-projective module. So perfect ring is defined with the help of two equivalent conditions here we are considering. R satisfies the descending chain condition for cyclic right ideal, and this is equivalent to, we say that R modulo JR is semi-simple and JR is right nilpotent. And in case of the module, we can say that if every module over the ring have the projective cover, then we call R is the perfect ring. So next result, we have to characterize the perfect ring. And okay, here this slide contains some basic properties of the semi-projective module. So if M cyclic submodule N is M principally projective, then this short exact sequence is split. Means here N is M principally projective and this is the short exact sequence. Then we say that this sequence is going to be split. Means there some map N to M exists whose composition with this one is going to be the identity map. And every direct summand of semi-projective module is semi-projective, and here M is the semi-projective module and F is the any endomorphism of M. Then kernel of F is going to be the direct summand of M if and only if image of F is the M principally projective. And next uniserial. So uniserial means have the linearly ordered in case of the submodules. So let M be the uniserial semi-projective module, then if this surjective endomorphism of M is an automorphism. Or we can state uniserial semi-projective module is going to be Hoppian module. So next is the result is semi-projective module M. If the M cyclic submodule of M is M principally projective, if and only endomorphism ring S is exactly equal to the collection of all F in S, where kernel of F is the summand of M. So next quotient module M modulo N of a semi-projective module is semi-projective, and this result is holds only for the fully invariant submodule N of M. Fully invariant means stable submodules. If N is going to be invariant under all the endomorphism of M, we can say F of N is contained inside M itself, corresponding to any endomorphism of M. So here we have to characterize the perfect ring and semi-simple ring in next result in terms of the semi-projective module. So R is the perfect ring if and only if the R module is amply supplemented, if and only if the semi-projective R module is amply supplemented, if and only if the semi-projective R module is supplemented, and if and only if the free R module is supplemented. So here supplements we call a submodule N of M is supplement of a module M. If there exists or if it is minimal with respect to the N plus K is equal to M, means K is the minimal submodule which exists in that case. And if this submodule is supplemented, then we call module M is supplemented. And in case of amply supplemented, so M is called amply supplemented if M can be written as A plus B, and the supplement of A is contained inside B. So such type of structure which exists, then we call module M is amply supplemented. So next result, we have to characterize the semi-simple rings. Which yes. So if ring R is the with Jacobson radical R is 0, means ring R is going to the semi-primitive, then this ring is semi-simple if and only if every semi-projective R module is discrete, if and only if semi-projective R module is quasi-discrete, And if and only if semi-projective R module is lifting, if and only if semi-projective R module is amply supplemented, if and only if semi-projective R module is supplemented. So these 6 conditions are equivalent corresponding to the semi-simple ring R. So here, first we call lifting if it satisfies the D1 condition, means corresponding to any submodule A of M. Our module had the decomposition like M1 plus M2, such that one component is contained inside the given submodule and quotient of other is small inside M modulo M. And so this is the module M is called lifting if it satisfies D1 condition, and means discrete if it satisfies D1 and D2. D2 condition is the if M1 and M2 are the direct summand of M, then their intersection is again a direct summand of M. And along with the D1 condition, module is called discrete. And quasi-discrete if it satisfies D1 and D3, means lifting and D3. D3 condition is defined like if M1 is the if M1 and M2 are the two direct summand of M, in D2 condition, if this submodule is isomorphic to the direct summand of M, then submodule is again a direct summand of M. And D3 condition is here, if M1 and M2 are direct summand of M, then their intersection is again a direct summand of M. So these 3 conditions is here. If satisfy only D1, then is called lifting. If satisfy D1 and D2, then is called discrete. And satisfy D1 and D3 is called quasi-discrete. And amply supplemented and supplemented is just discussed earlier. So next here we discuss the Hopkins-Levitsky theorem. So that one is the stated like here. Ring R is Artinian ring. Then this is going to be Nathaniel, and Jacobson radical R is nilpotent. This is the well-known Hopkins-Levitsky theorem. But this result is true only for the ring case, and many authors are investigated. This result is true in case of the module or not. So unfortunately, the answer is not correct. So in that case, counter example is given like this one. We have to consider the for any positive integer n and fixed prime p. Then corresponding to that, we denote m p to power n is the cyclic group of all the complex p to power nth roots of unity. So in that case, m p to power n means like mp square, mp cube, and so on. All are the cyclic group. And we construct the another group m star p, means taking the union of all these. So this one about this m star p, we can conclude here it is the infinite union of this cyclic group is going to be infinite, and these submodules are the cyclic, but this structure is going to be non-cyclic. And another property of this is here, if the proper subgroup is finite and equal to this m p to power n means corresponding from this chain, but this is not a finite. So here every finitely generated subgroup is proper and hence finite like this, and this one is not, means this structure is not finite, and in particular m star p is not finitely generated. So conclude about this, we can say yes. Yeah. Yes. So, oh, sorry. Yes, this group. So m star p is Artinian but not Nathaniel. So we can say that Hopkins-Levitsky theorem is not satisfied for the in case of the modules, because this is the m star p is the group over the set of integer. So this is the group over the set of integer forms a module. So we can conclude that every Artinian module is not necessarily a Nathaniel module. This Hopkins-Levitsky theorem is held in case of the module structure. But we have to try to investigate this structure is true in case of the semi-projective module, means extension of the projective modules. So module structure in particular, so this result is also not good. So in that case, we have to conclude here as a result. If M is Artinian and semi-projective module, then we have the property M is going to be finitely generated, and endomorphism ring of M is going to be perfect, and this one is semi-primary. And if M is taking indecomposable, then endomorphism ring S is going to be local. So with the help of this, we have to construct here the example of the semi-projective module which are not Nathaniel. So consider for in this case infinite set B as a basis, which is the countable basis for the infinite dimensional vector space V over the field F. So in this case, we have to construct the subspace of this infinite dimensional vector space, which is generated by the basis element Bi, which is denoted like V1, V2 up to Bi. Now define the linear transformation P on V on the vector space, and define like T of V1 is 0 and T of Vi is going to be Vi minus 1 for all I is greater or equal to 2. So this is the linear transformation. Now we construct the polynomial over the polynomial ring over the this transformation T. So here over the field here, then PT is going to be commutative Nathanian ring with identity. So here we have to consider infinite dimensional space V over the ring PT forms a module. So here this is the PT module, and it can be shown that proper submodule of V is exactly the Vi, which is generated by the Bi basis. And now we construct the ring R in the matrix upper triangular form matrix. Its F is our field, V is the vector space countably generated basis, and PT is the polynomial ring. And set M. M is the our upper means here first row matrix, which is considered as a module. So this M is forms a module over this ring. And one more thing, we see that M is the direct summand of this, and R is the ring. So R over itself is the free module. So M is the direct summand of free module is going to be the projective module. And if the projective module is the semi-projective, so this one is going to be the semi-projective module. Means M is semi-projective. Now, next thing we have to observe about this, any submodules, N of M is of this form, where 0, V, 0, 0, and Vi here. Where Vi is exactly the subspace of the vector space V. So, over the polynomial ring, this forms a modules. So all the submodules N is of this form. So this one Vi is the finitely generated, and now we can conclude M is Artinian cyclic semi-projective R module, which is not Nathanian, because this one is the descending chain is ascending chain is going to be not terminated here after finite state. So this is not Nathanian. Now we define here. If M is projective R module with trace ideal T, and R module N is called T accessible if and only if NT is going to be N itself. So our result in the positive sense is defined like misstated like a module M satisfies the ascending chain condition on T accessible submodules if M is Artinian semi-projective. So we can say here. Yes, sir.
Trace ideal, how to define trace ideal?
Trace ideal is ideal I is said to be trace if yeah, sorry sir, this one is not in my mind. Okay. Is there is a little confusion is coming there. So I will explain. Yes. So here we can state this result. If M is Artinian semi-projective, then this is going to be the Nathanian. So Artinian semi-projective is going to be Nathanian in case of the trace ideal T, means T accessible submodule in case of. So next result is here. We can discuss if R is a commutative ring and M is finitely generated R module, then M satisfies the maximal respectively minimal condition of some module if and only quotient ring R modulo n letter of M satisfies the maximal and minimal condition on for the ideal. So this result is also in case of the positive. So here we consider M is the Artinian semi-projective module with these conditions. Means R should be commutative, hereditary, and M is the generator for the category of right R module. Then M is going to be Nathaniel. Here hereditary thing means any finitely generated ideals are no. Every ideal is have the projective covers. Every ideal is projective. Then this one is the ring is hereditary. So these are the results on the semi-projective modules and based on the Hawkins-Levitsky theorem. So these are the references from based on the text we have to collect here. Next.
Okay. Thank you very much, Manu, for this wonderful talk. So, big hand to Manu for the talk. Yes, now it's open for question and comments, please. Yeah.
First of all, very nice talk, Professor Manus.
Yeah, thank you.
I have just one small query. So, like your essential condition and the chain condition, can you impose the small subtotal condition?
Yes.
Concept?
That one
Is it
yeah,
already
that
exist?
That one is already exist.
Okay.
Many authors are means here I have mentioned in the objective part.
Yeah.
Means we are discussing the chain condition on various contexts. So some author discussed about the chain condition on some modules and ideal. After that, someone is discussed some chain condition on essential. Someone is non-essential. After that, small and non-small. That one is the written by the professor on is from Allahabad University.
Okay. I see.
That one is professor. Yes.
There is any other question comment?
Can you go some previous slides?
Yes, please.
Where you were talking about polynomial PT.
Yes. Yes.
Yes. So what do you mean by polynomial generated by transformation here? This is a polynomial in P, capital T, or something else?
No, capital T. Oh, here is missing. No? Oh, sorry. This is the capital T. T is the transformation only. So, corresponding to transformation T, same transformation is here. Where transformation we define like on the basis element T of V1 is 0 and T of Vi is going to be Vi minus 1 for all I is greater than or equal to 2.
So this thing can be incorporated for polynomial ring as well?
Polynomial ring.
Collection of all the polynomials over, let us say.
Yes. So that one collection of all the polynomial over the transformation T forms a ring, and that ring is verified. This is the Nathaniel ring with identity and would be the quantity.
Assumption you started with consider the infinite set B, V1, V2, V3. So I'm saying like you can take this thing as 1 x square x cube for polynomial ring over set of reals or set of complex as well.
No, not here. We are considering the over the field F. So this over field F, we have to consider the vector space V, which is generated by the countable basis element. This one.
Same thing. My
Yes.
question is, sir, if you replace capital B by set of all polynomials over set of real numbers and field by set of reals or set of complex, the same thing can be incorporated there as well or not?
Yes. Why? Means we are considered here arbitrary field. So set of real is the and complex is the some particular class of that field. So we can do that one. I think no problem.
B is infinite set, you can do that.
Person.
B is infinite set.
Yes,
So
sir.
you can-
Here B is the means countable. This is the countable basis. So V is the infinite dimension. That's why we are considering this is the satisfy the descending chain condition. Means our
Now this question is different.
yes.
Okay. The question is can be generated polynomial over the set B. Yes, is that it?
No, what
No,
I'm
he is
saying
asking here polynomial ring PT over some field is also working or not?
No, my question is, sir, can you take this B1 as 1, B2 as x, B3 as x square and so on?
Yeah.
Consider the beginning assumption.
Here, means basis element is our one x square x cube.
Set of all polynomials.
Yes, that one is the basis element for the polynomial.
That
Yes,
will be a
right.
countable basis.
Yes, yes.
Dimensional vector space.
Right. Yes, say, that one is working. So this is the generalization. Means this is the in general we can take any basis element,
Okay.
not particular any the polynomial terms. No? So that one is the working pattern.
Any other question coming?
This is the this is the extension for that. That one is coming in the particular case.
Anyway, any more question coming? I have just one.
Yeah, please.
Since there are so many young boys, okay, and you are talking on pure abstract algebra and what theory. So could you give one or two applications so these guys will take in test in the project scenario?
Yes. Actually, these are the abstract things. So there is no direct application in our usual life. But these results are going to be helpful to prove the another result of the homological algebra and representation theory and so on. This thing. And one more thing, right now is application of the abstract algebra like group structure and ring structure is widely used in the anchor field coding theory and cryptography. That one is the application part of the algebra is mostly used. And means in my mind there is no direct application of the in our usual life.
So basically, I gave you the idea. Those who are new or working in computer science, the codes are considered as subspaces. Okay, over modules. So this is a very important part in coding theory. So if somebody are interested, can consider that as one of the aspects. You start on the beginning, like abstract algebra is not an abstract. Okay, you will take it as a tool and you can apply it in other science. Like so many parts, like real algebra,
Yeah, there are a lot of
field theory,
Yes.
lot of things. So I say my demand.
Means these are the abstract, so they are huge. Means that one is considered as the base for the other concept. We have to define another concept, so that one is considered as a base. With the help of this, we can found out some other concept and we can define.
Okay, so now to conclude, let's give hand to
Thank you.
Please come there, we give you a certificate on the behalf of the community.
Thank you, Professor Shakir Ali, for chairing the session. I now invite the session chair to present the certificate and memento to Professor Manoj Patel.
Where is he? Who is it? I'm just looking who it is. But she's not there. Oh, something more? No. There's more. Okay. Okay, we thank you.
Thank you, sir. A huge thank you to Professor Manoj Patel for that engaging and thorough keynote. The current perspectives you shared on module and ring theory provide a valuable foundation for the algebraic discussion we will be having throughout the conference. We will now pause for a much-deserved tea break. I request you all to kindly proceed to Auditorium 2. We quietly request that you return and be seated by 10:55 a.m. sharp, as we have an exciting keynote scheduled immediately after the break, joining us online all the way from the United Kingdom.
Yes.
Goswami, please. You guys can also join.
हमारे कन्वेनर को कन्वेनर ही गए अभी।
मैं वो मैम को ड्रॉप करने गया।
वो एक को जाना चाहिए ना, एक तो को टाइम आउट हो गया उनका, स्टार्ट करो।
Welcome back, everyone. I hope you enjoyed high tea and had some stimulating conversations. We now proceed with the next keynote address. We are thrilled to welcome our next speaker, joining us online all the way from the United Kingdom, Professor Ismail Al-Majid. Professor Najib obtained his doctorate in applied probability at the University of Bradford, United Kingdom. His work has been so revolutionary that he has been nominated by numerous high-profile academic institutions for the world's prestigious Abel Prize for the academic year 2026. This nomination recognizes his great services to humanity through revolutionary mathematical applications that advance several scientific disciplines, including engineering, computer science, and much more. Today, Professor Majid will be presenting on the captivating and cutting-edge topic, cutting-edge fractal geometrization for the next generation of science. Please join me in giving a warm welcome to Professor Ismail Al-Majid.
ब्रेकफास्ट कर रहा हूँ, मैं हूँ यहाँ पे। ब्रेकफास्ट कर रहा हूँ, मैं बैठी हूँ यहाँ पे। मैं हूँ अभी स्टार्ट यहाँ बैठे थे यार, अभी स्टार्ट हो रहा है, 20 मिनट के लिए रुक सकती हूँ। सर 2 मिनट रुक जाइए बस, 5 मिनट ये ज्वाइन कर देंगे फिर उसके बाद। किसी क्लास को बुला लो। धीरे से जाना शुरू होता है तो जो फॉलोअर्स बहुत सेंसिटिव होते हैं टकला और आना वापस।
Can we start?
Yeah.
Professor Mladik, can you hear us? His sound is not audible.
Sir, can you speak once again? You're not audible.
It is muted, I think. No, it is muted. Could you please?
Sir, I think you're on mute.
Yeah, please unmute.
So please unmute yourself.
I'm writing here, sir. He's on the WhatsApp.
Yeah.
Okay. Sir, there is an issue from your side. Could you please check once again?
Good morning.
Yes, yes, sir. Go ahead, please. Thank you so
We
much.
can go. Okay. Thank you. So can you see my slides now?
Yeah.
Okay. So today's talk is going to be about the cutting edge fractal geometrization for next generation science. In brief, what is a fractal? A fractal is a never-ending pattern that repeats itself at different scales. And fractals are extremely complex. Sometimes in financial physics.
Sorry, sir. Patel sir, you are the session chair, please.
Can you hear me?
Yeah. Yes. Go ahead.
Good. So I'm showing now my slides. Yeah. So the cutting edge fractal geometrization for next generation science. How can we use fractals? to change the way of the whole world around us, not for this generation, for next generations and ahead. This is exactly what I want to say. So we've heard about fractals, but how can we reshape the whole world of knowledge using fractals? So I'm now talking about three applications which is going to trigger your minds and blow your minds to see exactly how can we employ fractals in our life. What is a fractal? A fractal by default is a self-similar shape which appears at many occasions when you can zoom in and zoom out. When you zoom in and zoom out, you can get the starter from the microstructures to the macrostructures, from any particle below the atom and any particle beyond the multiverses by default. Having said that, the landscape by David Copenhagen can show you exactly how can you do fractals. Fractals could be in trees in front of you, so you can reshape the trees using fractals. We have the special features of fractals, as you can see here in front of you. Fractals have many features from the fine structure, starting from below the Euclidean, negative fractal dimensions, positive fractal dimensions, and fractional fractal dimensions as well, which showcases how can you do this to space-filling curves such as the Hilbert curve. When you talk about the Hilbert curve, I talk about aerospace engineering, using the Hilbert curve as well in spatial algebra and many fields. The first fractals have been discovered by the French mathematician Gaston Julia, with a very famous celebrated Julia sets. I'm giving you only a brief, but this is going to trigger your mind. So any interested researcher is almost welcome to join my platform for volunteering research to serve humanity. As you can see here in this image, fractals having the side shape and the projection. And this kind of fractals could be used as well in aerospace engineering and satellite imaging. So who can deny the beauty of fractals? You can see here how can you magnify the object to zoom in and zoom out for self-similarity. By default, many researchers have started the work of fractals, but one of the leading fractal geometrists is Mandelbrot, 1984. And here is Lindmeyer for his famous fractal tree to be held by his hands to show how can we represent fractals in life and in nature for trees. Getting again to fractal landscapes. So I'm going to only give a brief about the work, and you're almost welcome to give me any questions if you want. Fractal mountains. So how can you present geology using fractals, the shape of nature using fractals, the environmental shapes of nature using fractals? We can reshape summer, autumn, winter. Yes?
Huh?
Can you hear me? Can you hear me?
Yes, I hear you.
You can hear me. Great.
Hello.
Hello, yes?
Abdul Majid, how morning?
Professor Shakir, can you hear me?
Yes, I'm hearing you. How
Great.
are you?
I'm fine. I'm great. Can I continue, please?
Yes, I'm also here, but we have another parallel session. So I'm another session. It's good, brother.
So can I continue my talk?
Yes, you can continue, please. Yes, go ahead, please.
Thank you so much, Professor Shakir.
Okay.
Thank you. So I have the summer, the autumn, the winter, and the spring, and all of them are represented in a different landscape using fractals. So From the fractal foundation, you can see here in nature and geometry and algebra. And by default, this means that I can use fractals to do research with geometrists. I can use fractals to do joint research for nature. I can use fractal as well to do joint research with researchers in algebra, in all types of algebra. Again, fractal in nature, you can see how fractals are showcased like that. So this shows you how can I use fractals in biology, in geology, in landscaping, environmental science, and SDGs. Again, fractals again, the length of the coastline. So I can use fractals to get the length of the coastline. This could never be done using any other mathematics apart from fractals. And in this equation, you can see here the log n could be replaced, by the way, by the entropy to get something different, which is entropic fractals. And this is one of my specializations, by the way, worldwide. How can I use the entropy to represent fractals? And can I use fractals to represent entropy? So the meaning of dimension, we have the Euclidean dimension, xy, xyz for the 3 dimensions. Then we have xyzt for the relativity dimension, we have xyz and time perpendicular to the xyz. Then we have the fractal dimension, which could be, in brief, a number, real number, a fraction, or a negative fraction. Just showcase now the power of fractals, which could be beyond all the dimensions, rather than being Euclidean or Newtonian or Einsteinian. It could be something to be dominant. The growth of crystals in physics could be captured by fractals. I'm just giving in a brief of everything in front of you. The complexity of formation, of any formation, could be showcased and analyzed and modeled by fractals. This is fractals in geometry, as you can see here, and it showcases exactly how can I use as well programming using fractals. And can I use fractals as well to enhance programming in other case. This exactly shows exactly what I want to say. The lightning in nature could be represented by fractals mathematically as well. The oak tree. So in geology as well, we can use as well fractals as well to measure the age of trees. We can use as well fractals as well for the river networks in China. Huge research could be done using fractal beyond even all the limits. And studying plants, we can use fractals as well to see the shapes and the geometry, as how can we the structure of all the seasons as well within the plant itself using fractals. Here we'll come to algebraic fractals. So researchers who are involved in algebra can use fractals immensely and aggressively. Having said that, how can you use fractals in algebra? Here's one of the answers. This equation could be used to develop many algorithms, programming as well, and for algebra it could be used as well. The crystallization using fractals for the crystal canyon. This equation as well shows the morphologous, which is another modular set. How can we reshape this, and how can we get these designs and inspire ourselves to get more designs and more designs to describe the phenomena which could be never described by other algebraic autonomies. The Fiorino, another fractal, which created 300 years ago by Isaac Newton to describe the Neumann method for solving polynomial equation. You can see yourself here. So the work is phenomenal in brief, and we can use fractals in many things in our life. The Galanga, another thing as well, which is a snowflake village. How big or small the fractals we can have start from minus, plus, tens, and go on because of self-similarity. So we can describe the whole world, the multiverse using fractals, starting from the quantum particles to the macro particles, and goes on for the peacock. Other fractal in front of you here. The fractal dimension can capture the complexity and roughness of objects. So having said that, 2020, the owners for the Nobel Prize have done some work regarding how can I describe the edge between roughness, the complexity, and stability using probability. But I've done some other work which is more higher than their work on how can I describe the generalized Brownian motion using information geometry and fractals as well. So the complexity and complexity, wherever it is, could be used using fractals, could be modeled and optimized using fractals. Fractal cities. So I'm getting now to how can I describe now the urban planning using fractals? How can I describe the utopia of fractal geometry, which is a fractal city? Fractal design using architectures. So in airports, we can do more. This is an airport which was designed from A to Z using fractals. The crystals from the starting to the end could be described using fractals. Getting now to medicine. Can we use fractals in medicine? This is in your right hand side. You can see the fractal heart, and you can see the lungs here. The neurons in our brains, in our body, could be used by fractals for self-similarity, and we can use fractals in a different format, which will be mind-blowing. Fractal applications, the Hilbert curve, the computer chips, the fractal antennae, and many more. Using the Julia programming language, which is derived from the Julia sets, to do fractals as well, using just Julia programming language to enhance more programming language in computer science. And you can see here, how does it work? Fractal medicine, my favorite. How can you use fractals in medicine? This is a fractal heartbeat in front of you here, the lung cancer. And how can you use the fractal geometry and fractal dimension to measure cells? I have developed new work, which is mind-blowing, on how can I use mathematics to treat cancer. When I say this, how can we find the limit and the dimension of a cell and decide that this cell is going to be cancerous or not before even using any microscope? So I'm using my mathematics, my equations, to describe exactly when and how and why this cell could be cancerous. By this, I'm saving lives using mathematics. I'm using fractal geometry and fractal dimension to measure the cell and see whether it's going to be cancerous or not. And by default, this work has been already published. Step 2, this work have been used in Nigeria, and many researchers in Nigeria have started using my equations to do life planning and hosting in many hospitals using this work from this paper to start doing drug delivery and solutions to cure cancer, breast cancer under study in Nigeria, skin cancer, cervical cancer, lung cancer, and much more. And this shows you how can we use fractals in life to cure lives and to save lives using mathematics. Fractal anatomy. You can analyze the anatomy of the human body using fractals. For the vascular network, the neural network, the radial vein, the ulnar vein, the femoral vein, and all the veins in your body, the human body, could be described using fractals because of the self-similar patterns. Neural network. So when I'm talking about neural network, the human neural network, and as well the neural network as well in computer science, all of them could be merged using fractals. It's mind-blowing by default. Fractal viruses. How can we start from the healthy bone to the osteoporosis bone? How can we see and measure that this virus could be a deadly virus or none? from the dimensions of the very small and fine-tuned dimensions of this virus, which could be half, minus half, and so on. So using the fractal geometry, we can find the measure of a virus. We can find the measure of a tumor, a cell which is going to be tumorous or not for cancer. You can imagine vascular network on the fractals. Fractals in genetic is a different perspective of using fractal genetics. How can we use fractals to describe genetics and evolving from the mutations from A to Z? And curiosity as well. For the fractal application, could be used as well to generation the whole organs and transplant. We can use fractals as well to describe and get the imaging of all that. The double lens as well. By the way, my slides are going to be left to the conference and for researchers to see how can we use these fractals to enhance the way we look at science and the way we look at life as well, in every perspective you can imagine. Fractals in the film industry, something new as well. Fractals of many other applications as well for fractal escape and the signal of image compression, seismology, fractal in mechanics and solid mechanics, fractal techniques as well for data analysis, the visualization and the physical models, fractal and multifractal texture, the shape generation, render techniques, 2D and 3D fractal interpolation, image deionizing as well, the image indexing, the thumbnail imaging, and so many applications you can imagine. Non-classical applications, biomedical applications, engineering and mechanical materials, fractal cell image, and much more. From this much more, you can see here computer and video games. And more you can find. The more you dig for fractals, you can find as well with applications to do a new image of science. So it's mind-blowing. So basically, it's not even a breakthrough. It's beyond the way breakthrough because you use fractals to develop new sciences, new fractal algebra, fractal mechanics, fractal dynamics, fractal medicine. How can you use fractal mechanical engineering for the turbulence? So the fractal dimension of the particle clusters in isotropic turbulence using the kinematic simulation. Another employment of fluxes as well here. In chaos for music, you can use fractal music as well. The melody verse, the music fractal. The process begins by the Mandelbrot 3D creating by zooming loop of the tower-like structure. You can see the fractal in front of you here, all the images here for the music pattern. Fractal flowers for plants and study for plants. A flying fractal to design new balloons. The Mandelbrot set. So the scale of the image, the false color topography of the Shanxi province in China, the cast of human lung by old Weibel, and much more you can imagine here. The African architecture, you can see the fractal as well here. The fractal art, the fractal tree. And this fractal tree, by the way, is some kind of simulation using programming as well, the fractal programming as well, the Mandelbrot and Julia said programming to see the fractal tree. The simulated fractals and simulation for the range of the mountains. You can see yourself here. And all this work is documented, by the way, and these PowerPoints are with the conference for you to consult and see how can we use this to build new science from scratch. Simulated river networks. So this hydrology as well. What are fractals used for? Apart from all this previous literature about applications, random fractals, so include clouds. How can you measure the clouds? For the weather forecast, the coastline, the turbulence, and trees. These are some of my papers regarding the fractal dimension. How can I link fractals with applications to haptics, algorithms, and transportation? How can you link fractals as well to fractal geometry, to information theory, to queuing systems and source coding? How can you use fractals as well to enhance CubeSat technologies and education? And when I say about CubeSat, by the way, CubeSat is a very small satellite which is used for aerospace engineering So it's like in your palm hand. So this CubeSat could be enhanced using fractals, and don't forget about the fractal antennas and the Hilbert curve. And these are my websites here. You can see for the ResearchGate, the Scopus, the Google Scholar, the Web of Science, and the Cypress profile. Thank you so much for listening to me. It was a rare pleasure and honor to be with you today. Thank you.
Thank you very much, Professor Ismail, for your wonderful talk about the application of the factors in cutting edge application in the healthcare and algebra and computer science and other things. So here you have mentioned many applications in the computer science. So that research is already done or it's going on?
Sorry?
You have mentioned many applications of the computer science, means application of the factors in computer science.
Yes.
So, that are done already or is going on?
So your question is, how can I use fractals in computer science? Yes?
Yes, you have shown many
Yes.
applications here.
One of the applications, as I mentioned to you, is how can I use fractal programming? Fractal programming. Julia said programming. I want you to have kindly a pen and a paper and write what I can say to you, good self. Fractal programming, Julia said programming, the Mandelbrot fractal programming as well. How can I use the Python language and language as well to get the simulation of the Julia set, the Mandelbrot set, and the other sets I've shown, by the way, for the equations. Having said that, for fractal as well, it could be used as well to describe the patterns of chaos. So I can use fractal programming and other kind of programming to merge a new programming language to describe chaos. So chaos is one of the main features which are still under consideration for science. How can we get from chaos to stability? So the join from chaos to stability, this shows you how can I use fractals. Now, I can use fractal as well to start solving, and I've started already doing this problem. How can I start solving the unsolved problems of P equals NP, which is an NP hard problem? Can I use fractals to solve or try to get the solution of the P equals NP? Also, can I use fractal as well to solve the travel salesman problem, a long-standing problem for nearly 535 years? So this is one of the questions, by the way, one of the answers.
Yeah. Thank you.
You're welcome.
And you have used the Julia set. Could you enlighten on Julia set?
Sorry?
Could you enlighten the Julia set? You have used.
Yes, the Julia set.
Yes. How it can be defined? What is the kind of structure is there?
So the Julia set here. Just 1 second, because I got it from here.
Yeah, please.
Yeah. Sorry. I'm getting back again to my slides here. Yeah. So the Julia set here is from the first slide. You can see it here in front of you.
Your slide is not visible. You have not shared.
Yeah. So if you see my slides here, the Julia set is a self-fractal set which could appear as well. It could appear in many life applications. Definitely, you've seen something like a hurricane. The hurricane. Yeah, the tsunami. The way that tsunami itself as a hurricane moves around in the orbit is a Julia set. So this is to one of the real life applications we can see is the tsunami. How can we see the tsunami itself? The tsunami feature, the tsunami is a real life application of Julia set. So analyzing the tsunami is exactly as if you are analyzing Julia set. So we get the equation of the Julia set using the Julia programming to analyze the tsunami. So we're using Julia set itself is Julia programming is derived from the Julia set, and we can use it to analyze any self-similar feature or phenomena which is very near to the Julia set in a simple format.
Yes, yes, yes. Thank you.
You're
And
welcome.
any more? Any question, comment from the audience side? Yeah, please.
Professor Majid, it's a wonderful talk. I am Shafiq Ahmed from IIT Indore. I'm working on numerical linear algebra. So can you have something like your sensitivity analysis of the problem you are working and how you are doing this sensitivity if you do small change of your problem, how it reacts? And
So you are kindly asking, about, how can I use sensitivity analysis using fractals? Yes?
yes, yes, yes.
Okay. So in the literature, so some of my work, because I've done so much work regarding this. So basically, there is a new theory of fractal sensitivity analysis.
Yeah.
So I can use fractal as well for sensitivity analysis by sure. And if you are interested, I've left my email here. So my email is already there with Dr. Mamta and Professor Shakir. If you are interested to do, volunteer joint research with me, you are almost welcome, because there are many research papers regarding how can I use fractal geometry, fractal dimensions in optimizing the sensitivity analysis. So there's already existing, So, but the remit is too huge. So my email is already there. If you aren't kind of interested, you've got my email. You can get it from my contact from the conference committee, and you're also welcome, almost welcome to join with my research platform.
Okay, okay. Thank you so much. Thank you.
My pleasure.
Any more?
I'm ready to any question, by the way. I now want to ask, I give a question now to the conference, which is something different now. I'm going to ask the conference and all the audience here. You can see that fractals is already, this is, by the way, fractals is only one part of my work. I'm doing work with not even fractals, fractal geometry, queuing theory, and others. Because I always write in all different aspects of human knowledge, not even fractals as well. You can see here, all the audience can see that we can employ fractals in every single cell of our life. We can use fractals in algebra. We can use fractals in engineering, in medicine, biology, in biomedicine applications, biophysics application. So by default, what I am doing is already there and could develop all your research works by default. So whenever you find fractals, you can find other topics which are related to fractals as well.
Yeah, thank you very much.
You're welcome.
It was a very wonderful talk. So thank you very much. So we have to appreciate to the talk. A big hand to the Professor Ismail.
Thank you so much. Thank you.
Thank you, Professor Patel, for chairing the session.
My
A
pleasure.
sincere and profound thank you to Professor Ismail A. Majid for that insightful and visionary keynote on fractal geometrization. Your presentation truly demonstrates the power of revolutionary mathematical applications, which is exactly why your work has been so widely acclaimed. We appreciate you taking the time to share this cutting-edge research with us virtually from university. For our final keynote session of the morning, it is my pleasure to welcome Professor Shivakumar from IIT Madras, who will be joining us online. Professor Kumar is an exceptionally distinguished academic in the field of mathematics, having dedicated 22 years of service to IIT Madras, following 8 years at Anna University. He is an alumnus of IIT Madras, where he completed both his MSc and PhD. Professor Kumar is a leading expert in functional analysis, linear algebra, and optimization, and his foundational work is captured in his spring monograph, Infinite Matrices and Their Recent Applications. Furthermore, he is shaping the next generation of mathematicians to guide his 12-year PhD candidates and is known to many through his NPTEL videos on linear algebra. Today, Professor Kumar will be presenting on the topic matrices with most Penrose inverses at tree diagonal. I would like to welcome Professor Shafiq Ahmed as session chair for this session. Please join me in giving a very warm welcome to Professor Shivakumar.
Can you see us, Professor Siva Kumar? Here is Shafiq Ahmed.
Hi, Safiq. How are you?
Yeah, I'm fine. How are you?
I'm fine. I'm good. Yeah.
Okay. Can we start now?
Yeah. You can probably keep that video on, no? That international conference, that video on.
Yeah, video is on. Video is on.
No, the other one. The one that shows IE.
Video on home.
Can I start?
Yeah, please go ahead. Go ahead.
Yeah. Can you see my slide?
Yeah.
Yeah. Okay. So, good morning, everyone. It's my pleasure to be part of this international conference on advanced sciences and computing, recent trends. Let me thank Dr. Mamta Agarwal and Professor Safiq for the invitation to present my work. So the title is Graphs of Morton-Rosen versus of matrices possessing the triangle property. So, can you hear me?
Yeah.
Yes, sir.
Yeah.
The mic.
Yeah, you are audible.
Okay. Just give me a minute. Yeah. So there is graph theory terminology that I want to first introduce. I'll use this gamma to denote a graph. The vertex set is V gamma, and the vertices are denoted by V1, V2, etc. Vn, n vertices. The edge set is E of gamma, and the edge set is denoted by this pair Vi, Vj. This is not an ordered pair, so whenever it's not a directed graph, it's an undirected graph. That's the edge set. We say that vertices Vi and Vj are adjacent if there is an edge from Vi to Vj. The neighborhood of a vertex V is the set of all vertices that are adjacent to that vertex. And the degree of the vertex is the cardinality of the neighborhood. That's D of V. And you call a vertex a pendant vertex if the degree is 1, and call an interior vertex. Call V an interior vertex if the degree is greater than 1. A path of, just give me a minute. Yeah. A path in a graph, a path of length m is just a sequence of distinct vertices, Vi1, Vi2, etc., Vim plus 1, such that any two immediate vertices are adjacent in the graph. And a cycle is just a path where the initial vertex is the terminal vertex. And we know that if a graph is connected and acyclic, then it's called a tree. And one of the characterizations of a tree is that there is a graph is a tree if there exists a unique path between any two vertices. Is my presentation going through?
Yeah.
Okay. Yeah. Then I'm going to define the two important objects of study in this talk. One is a graph having what is called as a triangle property, and the other one is what is called as a tree diagonal matrix. So there is a graph on the one side and there is a matrix on the other side. So let's start with the triangle property. triangle property is a generalization of what is known as a triangle property. So starting with a tree, a matrix A is said to have the triangle property if the entries of the matrix satisfy a certain condition. So what is that condition? You take any three tuples I, J, and K such that Vi, Vj, Vk is a path. So what is Vi, Vj, Vk? Are vertices of a path. The path starts from Vi to Vj, for instance, and Vk lies in the path. Pardon?
Yeah, please go ahead.
Yeah. Can I go ahead? Can I go ahead? Yeah. Okay. So if you have a path joining Vi and Vj, take any vertex Vk that lies in the path, then corresponding to these indices, look at the entries of the matrix Aij.
Yeah, it's fine.
The condition Aij into Akk equal to Aik into Akj. This condition must be satisfied. So you take any three vertices Ijk, Vi, Vj, Vk, such that Vk lies in the path joining Vi and Vj. This condition on the entries of the matrix A must hold. Then such a matrix is said to have the gamma triangle property. So the matrix A, the property of a matrix A now is defined via a graph which is a tree. And so this is called triangle property relative to the tree gamma, and this is an extension of what is known as a triangle property of a matrix. For the triangle property of a matrix, there is no association with a graph. So this is an extension of that idea of triangle property. So let me give an example here. You take this tree gamma, and then we can verify that the matrix A that's given here has the gamma triangle property. For instance, if you take I equal to 1, J equals 3, and K equals 2, then you can verify. For example, first entry minus 4 is a product of 2 into minus 2, which is Aik into Akj. So this is the first object of interest, a matrix having a triangle property given a tree. Correspondence between a matrix and a tree. Given a tree, there may be several matrices satisfying the triangle property. That is clear. So this is just one example corresponding to this tree. The next notion generalizes what is called as a tridiagonal property. Matrices A possessing the tridiagonal property appear in a variety of problems in applied mathematics and engineering. So what is tridiagonality here? A matrix A is said to be tridiagonal if non-zero entries appear only along the principal diagonal, the super diagonal, and the subdiagonal. Such a matrix is called a tridiagonal matrix. The notion of tridiagonality generalizes that concept relative to a given tree. And so this is the definition here. So given a tree, a matrix A is said to be gamma tridiagonal. If Aij equal to Aj equal to 0 when I is not equal to j, and there is no edge joining Vi and Vj. So if there is no edge joining Vi, Vj, then the corresponding entry Aij as well as Aj are both 0. Additionally, when there is an edge, we assume that at least one of Aij or Aj is 0. So if there is no edge, then the entry is 0. The entry Aij is 0. There is no edge joining Vi and Vj. If there is an edge joining Vi and Vj, then we set either Aij or Aj to be non-zero. This is the way we define tridiagonality. So if this gamma is a tree that's given to you, then one can verify that the matrix A given here is a gamma tridiagonal matrix. It essentially means the following. For instance, you can always associate a graph to a matrix. Given a matrix, you can associate a graph in the following sense. There is an edge joining the vertices Vi and Vj if and only if at least one of the entries Aj or Aij is non-zero. So this is the way one defines the graph of a matrix. We use the notation G of A. So if you go back and look at this definition, what this means is that the graph of the matrix A is given by gamma. So any such matrix whose graph is the given graph tree that's given here in this picture is a gamma tree diagonal matrix. Okay. So as I mentioned, triangle property generalizes triangle property, tree diagonality generalizes tridiagonality. And what is the thing that connects these two? There is a result that was proved by Klein, which appeared in linear algebra application more than 40 years ago. Is my presentation going through?
Yes. Going.
Yeah. There's some the audio disturbance coming. Somebody mute. Yeah. So Klein gave this definition: tree diagonal matrices and their inverses. And what is the result? Take a non-singular matrix that satisfies the triangle property relative to a tree. Given a tree, take a non-singular matrix that satisfies the triangle property relative to a tree, relative to the tree. Assume that the diagonal entries corresponding to the internal vertices are non-zero. Then the inverse. So I have given some details here, but you can ignore a lot of them. What is important is that the inverse of such a matrix is a tree diagonal matrix. So this is the result. Start with the tree. Take a non-singular matrix that satisfies the triangle property relative to the tree that you started with. Make the extra assumption that the diagonal entries corresponding to the internal vertices of the graph are non-zero. Then the inverse matrix has the property that it is gamma tree diagonal. So it is a tree diagonal matrix relative to the tree that we started with. That is, in other words, the graph of A inverse is gamma, the tree that we started with. Klein also gave the formula for the inverse, but I'll skip that. We are using this in our work, but in this talk, this is not much relevant. So this is one of the main results that was proved by Klein. Non-singular matrix satisfying the triangle property, diagonal entries corresponding to the internal vertices are non-zero. Then the inverse, graph of the inverse is the tree that you started with. So here is an illustration just to consolidate this result. So look at this tree. Yeah, look at this tree having these four vertices. Consider the matrix A. One can verify that this has the gamma triangle property. So the triangle property relative to this tree. The matrix A inverse is this. And if you look at the graph corresponding to A inverse, you can clearly see that it is not tridiagonal. See, it is pentadiagonal, in fact. It is not tridiagonal, but then it is tree diagonal. So it's a tree diagonal matrix. So for instance, if you look at the first row of A inverse, forget the diagonal entries, look at the off-diagonal entries. The first row, second entry is non-zero. It indicates that there is an edge connecting 1 and 2. For example, if you look at the fourth row, the second entry, that's -4, it tells you that there is an edge joining 4 and 2, vertex V2 and V4. So that is tree diagonality. What also must be understood at this point is that if the tree that we started with is a path, then tree diagonality reduces to tridiagonality. So there is more than one way to look at these notions. So triangle property, tree diagonality, and the moment you fall back on the case when the tree is a path, you get triangle property or the tridiagonality of the matrix. So tridiagonality, when the underlying tree is a path, is tridiagonality. And so tridiagonality is a genuine extension of this idea of tridiagonal matrices. So this is one direction. That is, if A is non-singular, satisfies triangle property together with the diagonal condition, then A inverse is tridiagonal. The converse is also true. If A is non-singular, the graph of A inverse is a tree. Then if A is non-singular, the graph of A is a tree, then A inverse has the triangle property. So this is the inverse relationship. So the converse of the previous theorem is true without that extra condition on the diagonal entries. Non-singular triangle property implies inverse is tridiagonal. If the inverse is tridiagonal, then the matrix has the triangle property. That's the essence of this result. So these two results were obtained by Klein in this paper. And here is a quick example. If you look at the matrix A, this is a tridiagonal matrix relative to the tree that was given earlier. This is a 5-vertex tree. And if you look at A inverse, then you can verify that it satisfies the triangle property. Okay. Where do we go from here? If the matrix is singular, then we can ask the question as to whether the Moore-Penrose inverse satisfies this relationship between triangle property and the Moore-Penrose inverse being a tridiagonal matrix. So this is a question that we considered very recently, and we have obtained some results. I'll just give an exposure to what we have got. So before that, what is a Moore-Penrose inverse? I'm sure some of the earlier speakers would have spoken about this, but here is a short introduction summary. The Moore-Penrose inverse of a matrix is a unique matrix that satisfies these equations. These are called as Penrose equations. So given a rectangular matrix A with real or complex entries, one considers a rectangular matrix X of the order that goes the other way around. So if A is m cross n, then X is required to be n cross m, and X is required to satisfy these 4 equations. So AXA equals A, symmetrically XAX equals X. AX is Hermitian, symmetrically XA is Hermitian. So if these 4 conditions are satisfied, then it is called the Moore-Penrose inverse. What is known is that given any matrix A, there is an X that satisfies these 4 equations. Such a matrix is unique, and that is called as the Moore-Penrose inverse of A. The notation for the Moore-Penrose inverse is A superscript dagger. A superscript / dagger, that's a LaTeX command. DAGGER, dagger is like a short knife. That's the Moore-Penrose inverse. Moore-Penrose inverse existence comes obviously when the matrix A is square, when m is equal to n and the matrix is invertible, then the inverse trivially satisfies these equations. And so the Moore-Penrose inverse reduces to the usual inverse when the matrix is invertible. And so this is a genuine generalization of a matrix which is possibly singular, even rectangular. The existence of the Moore-Penrose inverse, there are many ways of proving the existence. One of the ways is to use a singular value decomposition. So if A equal to U sigma V transpose is a singular value decomposition, then A dagger, so there is a mistake here, then A dagger is V sigma dagger U transpose. Sigma is the matrix, it's a block diagonal matrix. The first diagonal block is a matrix of diagonals whose entries are the singular values of the matrix A. The rest of them are 0. And so one just consider the inverse of the diagonal. We always assume that the singular values are positive. The number of singular values is precisely the rank of the matrix A. And so the leading principal subblock there, the leading block there is of order R, that's invertible. And so if sigma is D0, 0, 0, then sigma dagger is D inverse 0, 0, 0. And there are some more specifications, but I'll skip that. This is roughly the idea. So use that sigma dagger, substitute into this formula for A dagger. A dagger is V sigma dagger U transpose. So this is one way of proving the existence of the Moore-Penrose inverse. uniqueness is proved by taking two matrices x and y, satisfying the equations, showing that x equals y. And quintessentially, the Moore-Penrose inverse has the following conceptual understanding. It presents a conceptual understanding. If the system of equations Ax equal to b has a unique solution that is given by A dagger b, if the system of equations have infinitely many solutions, then the one that's closest to the origin is the least norm solution that is given by A dagger b. If the system of equations is inconsistent and has a unique least square solution that's given by A dagger b. Finally, if the system of equations is inconsistent, has infinitely many least square solution, then the one that's closest to the origin, the minimum norm solution, that's also given by the expression A dagger b. So this is a concise summary of why the Moore-Penrose inverse is important. It is important in application, for example, in machine learning, regression lines are all computed using this concept, not the numerical process. So the question is, what is a version of Klein's theorem for the Moore-Penrose inverse? A is singular, satisfies the gamma triangle property with the assumption on the diagonal. Does it mean that the Moore-Penrose inverse, the graph of the Moore-Penrose inverse, is the tree that you started with? The answer is no in general. Look at this matrix. The rank of this matrix is 3. This satisfies the gamma triangle property, but the Moore-Penrose inverse, the graph of the Moore-Penrose inverse, as you can see, is not gamma that you started with. The graph of the Moore-Penrose inverse is something else. It in fact has a cycle. Yeah, so this is a graph corresponding to the Moore-Penrose inverse. So there is a cycle corresponding to the graph, and so it's not a tree. It's not even a tree. Leave alone asking whether it corresponds to the tree that we started with. Conversely, if a matrix is a gamma tree diagonal, then does the Moore-Penrose inverse satisfy the gamma triangle property? That is also not true. And I have given the details here. Probably I'll skip that. So both sides, both parts of Klein's theorem are false for the Moore-Penrose inverse. A may be gamma tree diagonal, but A may possess the gamma triangle property, but A dagger may not be gamma tree diagonal. A dagger may be gamma tree diagonal, but A may not satisfy the gamma triangle property. Both statements are false. So the question is, when is it true? That's a very general question. This general question is quite complicated. So what we have done is to consider the case when the matrix, so this is the general question. So let me probably show this also. So the first question is, how do you describe G of A dagger given that A satisfies the gamma triangle property? What is a graph corresponding to the Moore-Penrose inverse of a matrix satisfying the gamma triangle property? It's not the tree that we started with, but can we describe it? What is the description? Under what conditions? That's the second question. Under what conditions is this graph a tree? That's closely related to this question. The further question is, under what conditions is this graph the tree corresponding to the matrix A, which has the triangle property? So these are three different questions. How do you describe the graph of the Moore-Penrose inverse of the matrix A when A satisfies triangle property? When is it a tree? When is it the tree that we started with in defining the triangle property for the matrix A? So this is a very general framework. We have been able to obtain some results in the case when the leading principal submatrix, leading maximal principal submatrix is invertible. So if the matrix A is n plus 1 cross n plus 1, then we are assuming that the leading principal submatrix of order n is invertible. Then we have some results. The first main result is displayed here. It's rather too technical, so I'm going to just skip this. What it says is that, see, if you look at the last part, so what is the framework? A is a singular matrix of order n plus 1, square matrix of order n plus 1. It satisfies a gamma triangle property. Then, so what is the extra assumption that we are making? The leading principal submatrix of order n is invertible, so that we can invoke the results of Klein in our conclusion. This is the framework. then what we have been able to do is to obtain the graph description of A dagger. What is a graph corresponding to A dagger? And as I mentioned, this is rather too technical. There will be extra edges coming from the tree that you started with, but we give a precise description of the graph corresponding to A dagger. And so this is the description of that. So I am skipping this part. I'll just illustrate by means of an example this main result. So start with this 5 by 5 matrix. Start with this graph with 5 vertices. This is a tree. We can verify that this graph satisfies the gamma triangle property, the triangle property relative to this tree. If you look at A dagger, then this is computed in this manner. And then you look at the graph of A dagger. The graph of A dagger is this graph. So what you have got is two extra edges. Two extra edges. Those extra edges are between 2 and 5 and between 4 and 5. So earlier it was this tree. Now you have two extra edges, one connecting 2 and 5, the other one connecting 4 and 5. So there are two cycles here. So this is no more a tree, but this is what we have been able to show. This is a description of the graph corresponding to A dagger. And we also are able to characterize in this framework when the graph is a tree, and so that characterization is given. And the converse question also has been considered. A dagger is tree diagonal. When is A dagger gamma tree diagonal? We are able to show that this happens precisely when A has this structure. And here is an example that illustrates this theorem. So A satisfies the gamma triangle property, and A dagger is a gamma tree diagonal matrix. So I have come to the end of the talk. The idea is to look at a result which connects the triangle property of matrices and tree diagonality. For the case of matrices possessing the triangle property, if it is non-singular, then the inverse is tree diagonal, and conversely. What we have been able to prove very recently is that a particular analog of that result is true for the case of the Moore-Penrose inverse. And here are the references. The first one is Ben Israel's book on generalized inverses. The second item is this Klein's paper, tree diagonal matrices and their inverses. The third one is a paper that appeared in Special Matrices with my student. This considers matrices of order n plus 1 cross n plus 1 with the leading principal submatrix being non-singular. We are able to show that such matrices have triangle property, implies having triangle property for such matrices implies that the Moore-Penrose inverse or even the group inverse is a pentadiagonal. So this result motivated us to consider the case of the triangle property and tree diagonality. Thank you for your attention.
Nice idea you have presented here. Gamma triangle, triangle, and it's the inverse also gamma triangle.
Yeah.
But for the Moore-Penrose inverse, it won't satisfy. For the special cases, he wrote beautiful results. I think it would be very, very useful to you. It's the connection between the graphs and matrices.
Yeah.
Professor Shiva Kumari is very much on this, the light inverse and the matrix theory, in functional analysis. Very interesting talk. Now I am keeping this with the audience. If they have any questions, door is open for you. It's any question, audience? So if no question, so if you have any question further, you can write to Professor Shiva Kumar.
Yeah, sure. You're welcome.
Okay, thank you. Thank you very much.
Thank you, Safik, for the opportunity.
Thank you, Professor Shafiq Ahmed, for chairing the session. Thank you, Professor Shivakumar, for concluding our morning session with such a fascinating and detailed exploration of matrices and their inverses. Your work in the structure of Moore-Penrose inverses is highly specialized and crucial to the applied aspects of our field. We deeply value your contribution to the program and we thank you for delivering such an excellent presentation, particularly highlighting the power of linear algebra in contemporary research.
Thank you.
With that final keynote, we conclude the main plenary and keynote series for the morning. We now transition into our parallel oral presentation sessions, providing a platform for researchers to share their latest findings. The distinguished chairs presiding over the session are Professor Manoj Patel and Dr. Ajay Buj. Welcome, sirs. We have several engaging presentations lined up, and we ask the presenters to strictly adhere to the allocated time to ensure smooth flow. We begin with the first paper, ST005, Leveraging of Acupressure with Mathematical Modeling and Engineering for Migraine Relief. I invite the participants to come on stage.
Just a second, just a second. ये डाउनलोड नहीं हो पा रहा, आप प्लीज मेरे को मेल कर सकते हो?
किसी के पास दो पर्सन इनवाइट करना है, मनोज पटेल सर और लिखा है मैं शीट में पढ़ूंगा क्या? मनोज पटेल और अजय, हाँ,
So, a very good morning to everybody present here. First of all, thank you so much for inviting us over here, especially to Mamta ma'am, since she's been a really helpful guide for us. So, over here, we are here to present our research on how we're integrating acupressure with mathematical modeling for migraine relief. So, basically, over here, what we are doing is that we are creating a mathematical model for how the intensity of a migraine can be measured. And then further, based on how bad the intensity of the migraine is, we are trying to cure it using acupressure, which is a traditional Chinese medicine, which is basically saying that there are certain pressure points in our body. There are about 361 pressure points along 16 energy pathways in our body. And when you apply pressure on certain points, you can cure migraines to issues with pain all over your body and all that. So our focus is majorly on LI4, G20, and LV3. These are the three major points that we have taken for acupressure, and we've created a study based on these. So, of course, all of you know what a migraine is, which is a neurological condition, which basically ends up with having a lot of throbbing pain in your one side of your body, one side of your head mostly, and it's by side effects can also result in nausea or vomiting. Right. It can also result in nausea and all. And also from many migraine sufferers, we've also understood that a lot of light and sound sensitivity comes into play. And migraine, like it has a lot of mechanisms in the body, like cortical spreading depression, which is basically a energy pathway which is going from your spine. Okay. The reason why we have come up with acupressure as a result, as a way of treatment, is because there are a lot of drugs which are used for migraine relief, and usually they are recurring even after 12 hours, 24 hours. The migraine reoccurs, and it's not very effective. Also, it also has a lot of side effects in the body, like vomiting or having hormonal disbalance or some other issue like that. So we are going with acupressure.
So, acupressure points. Previously, the acupressure points used was PC6 and ST36, but we are using, first of all, we are using L14 point, L4 point, secondly, GB20 point, and third one is LV3 point. The first one point is large intestine 4. The point is present in the dorsum of the hand, like top of the hand, between the index finger and the thumb, which can, by the applying the pressure, it stimulates the trigeminal pathway, which can increase the cortisol blood flow in the body, and which can increase the release of the endorphin in the body. And it 83% efficacy in tension headaches like trials. We have taken the trials of the most of the patients. And the second one is GB20 point, gallbladder point. It is the main point in the body, it is present in the base of the skull in the occipital base occipital depressions. And we have mentioned here that direct stimulation of the gallbladder point, it greatly stimulates the occipital nerve and reduces the migraine. And it is regarding the light sensitivity. Like if a patient is suffering from the light sensitivity, then gallbladder point is stimulated, and it reduces the 25 reduction in the neck muscle, like EMG activities in the body. Third point is LV3 point, like liver 3 point. Its location is the dorsal foot between the first and the second metatarsal in the feet. Okay, the second point is vagus nerve activation, which increases the 30% blood flow in the body by stimulation. Then cortisol reduction by 80%. Like cortisol, we know that it is the major stress hormone in the body, and it reduces by the 30% in the body and 18% in the body. The second one is 62% greater pain reduction with Li4 combination. When LV3 is combined with the Li4, here it is new point. When the LV3 is combined with the Li4, it uh, reduces the pain in the body. Like if a patient is suffering from the back pain or headache pain, then Li4 and with the combination of LV3, we can reduce the pain. Like previously SG36 and PC6, both were the points, but we have not taken the points. Like it is regarding the nausea, vomiting. But we have gone for the heart point, headache point, and the third one is uh, whole body point. So we have gone through that. Next one is Somajit.
So now I will talk about the mathematical model that we have built. So there are many parameters for migraine, like migraine intensity and serotonin release, treatment effects. So we have combined it using differential equations. And first, we have taken the all the parameters like intensity directly depends on the neural stress. So it increases with the increase in neural stress, and it decreases with the with the treatment effects, and it also decreases with the release of serotonin. So we have combined all of this in a mathematical model using differential equation. Then the second is uh, we have also modeled the neural stress levels. Like you can see our papers for the mathematical models, where all the models we have given equations. So in that equation, the neural stress depends upon the treatment effects, and also the neural stress reduces by the body itself. Uh, Next is the serotonin concentration. Serotonin concentration is balanced by the body. When the stress is high, serotonin releases, and then it decreases automatically by the body to make the balance. So next is our treatment efficacy. So with more treatment, we have used constant a constant level where our treatment we show how our treatment is decreasing the effect of migraine, that we have shown in that. And generally using this differential equation, we have found out that treatment like acupressure on migraine works for 8 to 12 hours. After that the effect decreases. Like other even medicines, normal medicines, the effect also decreases after some time. So we need regular acupressure to maintain that balance, to maintain the effect of the treatment. For our modeling, we have used Rangaputta model of Rangaputta mathematical model we have used for this differential equation modeling and combining it. And uh, we have also made like using this model, we have made some values. We have taken some values of some patients, dummy patients, to show the effects, like how the effect is working on them, how the treatment is working on them. It is getting better, and then after we have taken like after uh, every 6, 8, 12 hours, how the treatment intensity is working. We have done that in our paper. Further will be explained by.
Okay, so now we look into the results and the observations that we have obtained with the mathematical model we created. So as my teammates spoke about the mathematical model, the parameters that we're using. So about the patients, we have observed different migraine intensities in each patient, and we have calculated the migraine intensity and the other parameters using these equations. The result that comes up is varying from patient to patient, of course. We can see that over 48 hours, like my teammate said, that about 12 hours later, the effects they start decreasing. So we need regular acupressure. And after 48 hours, we can see different signs of improvement or different intensities of improvement in different patients. Some they observe a high level of improvement. They can have a high serotonin level. They have greater pain relief compared to others. So this is mainly observed in case of chronic migraine cases, wherein the patients are experiencing a lot of headache, a lot of throbbing pain, intense throbbing pain. So they have observed increased serotonin levels and reduced pain, significantly reduced pain. Further, we can see that some patients they observe mild migraine, while the others they have intense severe migraine. So it is our insights they include that optimal treatment frequency is approximately up to 48 hours or 2 days entirely. So GB20 is the most effective, as we can see, and LV3 it also reduces the pain up to great level. As for our concerns, we can observe that not all patients they have observed the same things. Obviously, there are different intensities. There are different ways each body would respond to the treatment. Each patient would respond to a treatment. So our observations include that fairly good amount of patients have experienced a great pain relief and a significant increase in the serotonin levels, which has caused a great improvement in their condition, at least over 12 to 48 hours. So with that, we conclude our study. We can see that with our study, we have observed that our mathematical model, it qualifies for an effective treatment if continued on a regular basis. We can also see that it opens a new pathway for future therapeutic discoveries. Also, we can see that the framework validates traditional medicine, that is the traditional Chinese medicine, that is acupressure. It validates for further uh, discoveries in the medical field. We have also observed this acupressure to be effective in several other cases, such as pregnancy, nausea, vomiting. We have also observed that post surgeries, a lot of patients they if they have significant pain after the surgery. So giving them acupressure up to 48 hours or up to 12 hours, it has improved their condition. It has helped them heal faster. So with that, we conclude presentation. Thank
So here is your model. You have not shown what is the your model is.
So that's actually in the paper that we submitted, and this was actually very last minute. So that's why
Models.
not here.
Models should be there in the presentation. Without models, how we understand?
So this is the only analysis overview you are giving.
Right.
So just you have to show here your model. Is this one is the sustainable or not? Is solution is exist or not?
So, as per all the research and literature that we have read, our model is very, it's a theoretical model. There is no physical proof for it. Even the patients that we used were dummy patients. So it was based on data that is already provided in the literatures before. So we just used those values and we integrated it with our model to get a certain amount of graphs that we found out.
So from where you have to collect your data?
So we referred to a lot of research papers, and then based on so every pressure point that you see,
From which journal you have to collecting that research paper from where your data is collected?
So we actually we put up a very wide research based on migraine and on Google Scholar and ResearchGates only. And then
My question is here means so many research paper is here dummy research, no?
Yes.
In India and outside India is
Yes.
also working like that one. And
there
they
is-
are collecting the data is someone is putting, and we have to collect that data. But not that data is maybe authentic, but somehow is we are not believing on that. So, what is the authenticity of your data, and you have to means develop your model. Then is that model is exist or not? So
whatever we have. So there is no mathematical for any acupressure or for any migraine relief or anything like that. So our model was purely based on the parameters we found out from various papers, like how neurostress is affecting migraine, how serotonin release is affecting migraine. And based on these parameters, we came up with a mathematical model, which was not like it was purely theoretical. So there is no physical proof whether the model actually works or not. And then or after that, we found on how migraine intensity is usually calculated, which is based on neurostress and all. So we took up a very broad-based spectrum of finding out the parameters for again the same. There is no proof or data per se that acupressure intensity will be this much only, or any other intensity will be this much only. It's on like again, it's like we said, it's patient to patient. So similarly, the model over there, pain intensity, also works on patient to patient, and therefore the people who told that the intensity is, they've also given us a range. So based on that range, we try to narrow it down for our own needs.
Yes.
So again, it's theoretical. There is no
She
so
will-
our paper,
I have to send her the link.
the theoretical
When she will-
values are all
Yeah, I will
theoretical. They don't have any authenticity in the sense of
But
giving patients.
it's still working.
Yes, that is working.
What is your contribution in that case? Means just you have to shown here, this one is working, I have realized this. And other, what is your contribution in that?
So basically, what we're trying to do over here is that we're trying to remove. So my friends, they currently suffer with a lot of migraine. Okay, she has chronic migraine. So the issue that we're facing, is she has to take a lot of pills and medications because it's usually hormone related or it's other stress or anything like that. So we are negating the pills and we're trying to use acupressure instead. And like we said in the paper, like after analysis, GB20 was one of the most used pressure point, right? Earlier it was PC6 and ST36. So what our contribution to this is that once we are able to like give physical proof that our mathematical model works, we intend on giving acupressure points based on that. So what we observed is we took 5 patients with very mild migraine and we took 5 patients with a chronic migraine pain. And we observed that in mild migraine, the pressure points, even though they work pretty well, the intensity of reduce is not as significant as it is there in chronic migraine. And that's also because different pressure points were used for all these patients. So basis on this, we intend that once we quantify how much migraine intensity is there in a person, we can choose what pressure point also works. Because there's so many pressure points in our body, like I said, 361, right? So the issue that also sometimes comes up is that if the way the acupressure is provided is wrong, then the intensity will increase instead of decreasing. That's also something we observed in our study. So, like for all migraines, if it's a mild migraine, you don't need GP20 to actually cure it. It can be cured with Li4 or Li3. So, based on that, our like we are trying to quantify migraine intensity so that the way we provide the relief is also measured in that way, so that however intensity is there, we can reduce it.
This is the only analysis we have shown. And if you are showing your model, then some question is
Right, sir. I understand, sir.
So here you are telling the Runjaputta model you are using. What is the base of that?
The differential equation model we have made, we have combined it using the model.
For numerical.
Yes, sir. Yes, sir. For the communication passage, we are
Yes, giving the some iterations of iterative solution. So, what is the guarantee that one you have to cover the whole the domain, and on all means covering the domain, our solution is going to be converging.
Sir, like for our model, we have seen that on the acupressure, after giving the acupressure, treatment intensity works for 8 to 12 hours. After that, it reduces exponentially.
That part is good. So we are coming from mathematical point of view. Means we are generating the differential equation. After that, we have to convert for the numerical solution, apply the RT method. No? So in that case, my question is, means some time interval you are using.
Yes, no? Yes.
So in that time interval, what is the guarantee our means effect of the applying the method is going to be converged to the time.
उससे चलेगा ना
Taking the pain.
लाइव शुरू हो जाएगा फिर से एक और लाइव होगा अभी प्रेजेंटेशन हाँ काम हो जाएगा उसको चला एलिफ ऐड होगी शायद एलिफ
Just a second. She hasn't.
Like
She hasn't joined meeting.
But for some, it gets worse when we use the model.
Have you compared with the other already existing model in solutions? Have you compared your solution?
Like I said, there are no mathematical models that we could find per se for migraine intensity or anything like that.
So instead put this one,
So,
there is no existing.
Mathematical model, we cannot find any. We were only finding like basic, like what migraine is, how studies on migraine are conducted, and how on a neural level migraine intensity can be seen. But there is no mathematical model that we could find per se. We tried to find a lot of research. We were not able to find anything in mathematics per se. So that's how we came up with the mathematical model. And for the time intensity search, we had taken up four values. We had taken four time intervals. First interval was 6 hours, second was 12 hours, third was 24, and then it was 48 hours. Like when we were conducting these studies, right, that time we saw that in the 6 hour period, the intensity had significantly reduced, but the same intensity was not reduced in 12 hours. So when we provided relief again in 12 hours time, we saw that up till like 18 hours, the improvement was there, and then after that, it started becoming constant and it started decreasing. So on the basis of that, we wished that within 8 to 12 hours range, an acupressure therapy would have relief with the patient. So yes, based on that time period, we found.
Very well. Thank you.
Thank you, sir.
Where is your references?
Sorry, sir.
References, research for references to
Yes.
There is no reference. How many research paper you go through?
About 25 to 30 pages.
Then research paper. So when you prepare the presentation, models should be there, references should be there, yes or no? And conclusion should be. See? Yes. Thanks. मैम कौन है क्या
सर अभी स्पीकर का जस्ट कंफर्म वो वहां से ज्वाइन कर रहे हैं
ऑनलाइन कर दें
हाँ स्पीकर है वो बट आप करिए
ठीक है
हाँ, अच्छा है आपसे आप मिशन शेयर करेंगे मैं उन्हीं को कनेक्ट कर रही हूँ ऐसे सो एलिफ को वेट कर रहा हूँ
अब हम बात करें मैं गूगल को नहीं टेस्ट किया मैं सॉरी ऐसे बोल भी नहीं सकते हैं कि हम बोलेंगे चल बनाएंगे तो हम नहीं बोल बचने का मॉडल तो होगा सभी तरह इसकी सोच करते सभी तरह मेरे से कहीं ना आप बंद खाने things change after
Any of the presenters, ma'am?
I kindly thank the team for that intriguing presentation. I would now like to invite Dr. Elif to join us online for the next oral presentation.
Hello everyone. Can I start? Hello everyone. And
Yes, ma'am, you are audible.
okay.
Morning.
It is an honor for me to be here and a speaker at this conference. I would like to thank you to the organizing committee and for their kind invitation. Today, I will share my screen. Just a minute.
Professor Elif, am I audible?
I can hear you.
Hello, am I audible? Hello, Professor
Hello.
Elif, am I audible? Am I audible?
Yes, I am available.
Hello.
Can I start?
Yeah, you can. Welcome in this RTSC presentation. Welcome you. Hello.
Okay.
You can start. You can start.
I'm
Thank you.
starting. Okay, thank you. Thank you.
Session chair will be by Dr. Ajay Kumar Guruji. Sir, welcome.
Okay, thank you. I share my screen. Okay. Can you see my window? I think it's okay. Okay.
Yes, continue. Thank you.
Okay. Today, I will explain the fundamental source of the reversibility problem, actually DNA reversibility problem. What is the main motivation, or what we did the solution, or what did define how we define the reversibility problem in literature. So firstly, I will provide some fundamental background information on DNA. Everybody knows DNA consists of 4 bases: adenine, cytosine, guanine, and thymine. And the Watson-Crick base pairing system is working in I'm sorry. Is working in the DNA helix structure, like that. And we know that in Watson-Crick base pair system, the base A, pairs with the T, and the G pairs with the C. So complement of each other. And this is the small sorry, my computer. Yes, this is the example of the DNA strings. This line is complement of the other lines, like that. The other important things is, oops. Sorry, there's some problem about the PDF file. I'm reopen it. Okay. Another important things is the reading direction in DNA, because the some a protein, the name is the DNA polymerase, generate the other site in DNA string by using the reading direction. For example, when we get I will extend it. And I want to close this. Okay. When we get these parts, this is the first part. And we consider the complement of this part in here. But the direction is the reverse of the first one. Oops. So when we create a algebraic codes according to DNA basis, we get the first line, this one, as a algebraic codes, and the second one, the complementary side, we get the reverse part, because we consider the DNA parts with same reading direction. So this is the one of the main idea why we generate the reversible complement DNA codes. Not only reversible code or not only complement code. We need the reversible complement DNA codes. So this is the working of the DNA polymerase. It generates the other strings from the one DNA strings, and the important things is the reading way or reading direction. So when the DNA computing idea starts, it is important. In 1994, Leonard Adleman solved the Hamilton path problem in a test tube. And really, he used some synthetic DNA parts, and he used a test tube, and he worked in a lab. So normally, Adleman is a computer scientist. So he is one of the inventor of the RSA public key crypto system. So this is really interesting for me, because he is a computer scientist, but he works in the biological lab. And he explained the story of this testing time in here. This story is very good story. He explained it. And the main paper of this test in here. So the DNA codes is very new area in literature. So what is the Hamilton path problem? The main idea, we have some cities and we have ways.
Where should I start? Like, what would be your favorite first thing to learn about mathematics if you've learned so
So the easiest one is calculus, and then I think that you have that code.
Yes.
Yeah.
I do have calculus, linear algebra.
सर वो ज्वाइन कर लिया उन्होंने नहीं जा रहा था ना
Do you have a question, because I can't hear you very well? Can I continue?
सर आवाज आ तो नहीं लेकिन स्लो है
I don't understand.
James मैं अपने से ज्वाइन करके बात कर देता हूँ
Okay, I'm continue. And the Hamilton path problem, it is important, especially cargos and flights because we will start the cities and we have to visit all cities in using only one road. We can't use one road 2 times, but we don't need to use all roads. The important things is which is the shortest road, because we can define the shortest road or shortest ways. This is more cheap the other ways. The money is important in life, so Hamilton Path is very important problem. Now I will explain the Adleman experiment with small cities and small DNA codes. Let's choose 4 city and flight routes like here. In normal experiment, I think in the Adleman choose a 7 city and 20 length DNA bases. I have 4 city, and my aim is how can go from Atlanta to Detroit with visit the other cities. So I have to go to Atlanta, to Boston, Chicago, Detroit, or Atlanta, Chicago, Boston, Detroit, which is the shortest and which is the suitable for Hamilton Path. And firstly, Adleman give a DNA name to cities. I give short names like this. And in test tube, we use this complementary site. In test tube, we use this site. And DNA flight number, and so we can obtain the DNA flight number. And the DNA flight number can be defined by concentrating the last name of the origin city, like that, and first name of the destination city, like that. The Atlanta flight number, this part is last name of the Atlanta, last 4 bases, and the DNA flight number of the Atlanta Boston, last 4 bases is the first 4 bases of Boston DNA name. So after this choosing the DNA name, complement, and flight number, the aim is to solve the Hamilton Path problem. This means that we have to construct a route of the minimum length in which every city included. So we Adlemans, for the Adleman test tube experiment, multiple copies of the complement DNA names add in test tube. After that, multiple copies of DNA flight numbers add in test tube again. And after that, we generate lots of strings and with different orders in cities. But this is shortest and optimal, and it's solved. It is a solution of the Hamilton Path problem for these 4 cities. We can obtain, or Adleman obtained, this solution. So when Adleman did this experiment, he solved this problem within 2 minutes, but separate all of the strings, it got maybe 2 weeks. So this is also an open problem. So DNA computing or DNA computer has more improvements actually. And after that, so why we need the minimum Hamming distance in DNA codes, or why we need the reversible complement codes? Firstly, I will explain the errors in DNA. For example, if we choose Atlanta name like this and Boston name like this, and complement of this name is here, and there is a problem. because we add the complement of this name in test tube, they will connect each other like a different string. They can't be stay like a line. They can connect like this each other, and they can blend and connect. This is an error. So in test tube, yes, we can. This is the desired type, but it can be error like this. They can connect each other. If they have a small difference or small errors, the DNA can, how can I say, can correct or can don't consider this error, and they can connect again, or Boston or Atlanta and bend and self-connect. This is error. So according to these errors, we understand we need some difference between the DNA names or half of DNA names, especially. For example, we know that these strings, and we consider the half of this string as a code word in error correction codes. We aim that how can we generate this DNA part, the others, with minimum distance, because we have to separate, we have to satisfy when we add these DNAs in test tube, they can connect wrongly. If they have a optimal minimum distance between each other, they can connect wrongly. They can connect only their own complementary site. So we can solve again the Hamilton path problem, and very easy way according to DNA Adleman experiment. So this is the main motivation of reversible, generating the reversible complement DNA codes. So we need to, end of this studies, we need to obtain this line, this generated by some error correction codes. In literature, there's some studies like mixed structure and DNA like that. This is not true according to main motivation of the Adleman experiment. So according to this main motivation, we ask, or researcher ask some problem. How can we obtain reversible and reversible complement set with a distance? In coding theory, we know that this problem in coding theory, how can we obtain codes in normal problem with the optimal distance? In here, how can we obtain reversible and reversible complement codes with a distance? And so how can we obtain these codes as a DNA with optimal bonds? Optimal bonds, getting optimal bonds in DNA codes is still open problem, because when we get the optimal codes in finite fields or rings, when we convert the DNA, nobody knows now. How can we get the optimal codes? Because when we convert the DNA, the space is changing. So this is a still optimal codes, still is an open problem. Sorry for that. And I'm continue. And do I have a more time, or it's okay? Hello?
Ma'am, you can continue.
Okay. Please say me if I have no time. I'm continue.
Ma'am, we have 10 more minutes. You can continue.
Okay, 10 minutes. Okay, thank you. And where is the reversibility problem in literature? And of course, DNA computing is a really huge area, and cryptography, DNA storage, DNA computer, and real DNA computer. And some researchers I heard they try to create this interesting. And so there's a more different algorithm. And the reversible problem stay and placed in here, I think, and it continues to extend in this area. Reversibility problem is mean the DNA reversibility problem. First DNA codes with error correction codes is created by the Taher Abu al-Rub in 2006, and they consider an algebraic structure 4 elements. Also, Professor Shiab in 2006. Also, he considered the algebraic element, algebraic structure that have 4 elements. If we have 4 elements, then there's no reversibility problem, because when we get the reversible codes, for example, we have a code word, the first one, and it's correspond to these DNA codes. And when we get the reverse of this code word, we get the reverse of the first one, the DNA code. There is no problem. Problem is start, and this is a reversible code and reversible DNA code. And for F4. So we have 4 elements in algebraic structure. We have 4 bases. There is no problem. So in 2012, the Professor Yıldız and Shiab tried to use 16 element for DNA, but they didn't do. They didn't solve the reversibility problem, or they didn't define, because end of this study they delayed one of the bases. So when for a code length 5, they have to get 10 length DNA bases, but they delayed 5 of DNA parts. So they didn't solve and define reversibility problem. What is the reversibility problem? When we take algebraic structure that have more than 4 elements, especially 16 or power of 4. For example, we have an algebraic structure, so 1 element goes to and more than 1 basis. In here, 1 algebraic element goes to 3 bases. So this is our codes. This is our DNA codes. It's okay. But when we generate the reverse of these codes, we can get these DNA codes or these DNA strings. In this area, the notation and the definition not stable. Sometimes researchers says the codes, and sometimes they say strings, and like that. And we can get this one. But the second code words is reverse of the first code words, but in DNA side, the second one is not reverse of the first one. Then I defined this is the DNA reversibility problem in 2013. So I thought, how can I solve this problem by using the algebraic structure that have more than 4 elements? And firstly, I solve with F16, finite 5, F16. And after that, I solved the general of this finite field with this paper, lifted polynomials and application. like that. I will explain in an example, and this is the reversibility problem again. I'm showing you, and my main motivation question was how to generate reversible code with different way. This is still my main question because I generated the lots of methods to generate reversible codes with different way and the different method. The another question, how to generate reversible DNA code over F16. Actually now our open question is how to generate reversible DNA codes over another algebraic structure that have more than 4 elements. So it means we can get the reversible DNA codes we can obtain the reversible complement DNA codes easier than the reversible DNA codes because the important problem is the solving the reversibility problem. Complementary side can get automatically, we can create the, how can we define DNA bases and they consider the algebraic structure elements like that. I will skip this part because the main idea of this presentation is explain the DNA reversibility. And in 2013, I defined this notation, and I think in the literature, lots of studies use this notation. And in finite fields, I create this correspondence table. But in rings, we can define according to algebraic structure. We can define a small corresponds, and we can generate huge corresponding rules. But in field, we have to create a table. This is also an open problem. How can we solve the reversible DNA problem in finite fields without creating a table? Because when I used more finite fields that have more elements, I have to create more bigger table for this. This is also an open problem. And in this table, there's some properties important. If we add 1 to these elements, we can obtain the complement of this parts, DNA parts. If we take the 4th power of the finite fields elements, we obtain the reverse of the DNA parts. This is the trick of this table. So we solve the reversibility problem by using this method. According to this method, we create the generating method and matrix method and the lifted polynomial like that. So I will show, and this is our code words, an example, and this corresponds this part. We have the code words length of 4, and we have the DNA codes length of 8. And this is the lifted polynomial. I will skip this one. And we can generate reversible optimal codes. And this is the 4 lifted for reversible to DNA. Yes, in here, we create a generator for reversible DNA codes, and we obtain the reversible DNA codes with these parameters in DNA. But in normal time, it has, I think I didn't write here. Okay. This is this the optimal codes in DNA side is still open problem. Because we can optimal codes in coding algebraic side is not problem. It corresponds to reversible complement DNA codes is not problem. But we don't know the bounds for only DNA. This is the funding bounds only DNA as open problem. And yes, when we add this line to generator matrix, we can obtain reversible complement. This generate the complement side of the DNA code. We can obtain reversible complement DNA codes, and we solved firstly in literature reversibility problem. And firstly, I defined the reversibility, DNA reversibility problem. So it is good for me because I create a new definition and new problem for literature. There's a, I think this is the old, and also there are some definition I created in literature, lifted polynomial module codes, its name as a G code, and FQ reversibility. Also, there's a question maybe someone wants to ask, why we use only 4 elements and 16 elements? There's no obligation. I think we published a paper with Professor Shakir Ali. We used 5 elements or 18 elements for DNA codes because we know only 4 bases, but there is some different bases. For example, letter N, it's correspond to also 4 letter, and someone can ask or someone can check the internet. There is lots of kind of the base or something like that. So this is not limit. And thank you for your patience. And do you have any question for this?
Thank you very much again. Are you hearing?
Yes, I can hear you.
Are you hearing me?
Yes, I can hear you.
Okay, thank you very much for wonderful talk and giving a lecture in the conference. Okay, one just remark. Okay, here we have undergraduate students, and you are talking DNA because DNA related to the medical science, so they may have question how your mathematics connect with DNA. Could you give the remark to the undergraduate students?
Could you please ask again because I can't hear you very well.
We have some undergraduate students, okay, as a participants, and your talk based on a DNA code. So my question is DNA related to the medical science.
Yes.
So how this mathematics connect with the DNA? So maybe the students eager to know. Could you give remark? Is how the algebra connect with medical science?
In medical science, there are lots of questions. And when you speak with a doctor in 5 minutes, you can understand they don't know anything about the connection, and you can solve. And I can suggest to students, please be curious, and there's a lots of problem.
This is the beauty of mathematics, okay? Anyway, thank you very much. Now I have some more questions, please.
Yeah. So just switch on the mic. So switch on the mic, please.
Thank you, Professor, for your nice talk. So just I have a query. So you are getting a matrix. It's kind of some structured matrix. It's a special kind of matrices that I am curious, and it can be a big matrix as well with your polynomial, the one you are generating. Yes.
It is a
Generally,
special matrix that I generate. Yes.
yeah, generated matrix.
It's not cyclic codes or like that. It's I created this method.
Okay.
Okay.
So it's a kind of some structure like a tridiagonal, or it is a.
It's similar to. I can show you.
Because your matrix is sparse, you know.
Yes, it's similar
Yeah.
to the cyclic codes, but it has a limit. I slide and I create cyclic, but it's a limit, and I have no big one. But here, yes, I choose only in matrix. I lift the coefficient in here like that. The main idea is that. After that, I add the matrix and I shift, but it is not cyclic code also.
Basically, this is what is the name of such kind of matrix? That is question.
Ah,
Oh, yes.
lifted code matrix.
Yeah.
Because I did it. It is my invention.
Yeah. Okay. Thank you so much.
Okay. Okay.
So thank you, Arif, for wonderful
Okay.
talk. Oh,
Thank you for your invitation and this good conference. Okay, bye.
Thank you, ma'am, for that informative and intriguing presentation. I would now like to invite paper CT012, a lightweight deep learning model for the real-time fire and smoke detection using CCTV footage. So please join us on stage. I also request all speakers to limit their presentation to 5 minutes and 2 minutes for the Q&A session.
दिवाली है ना या
okay, Arif, you can now go enjoy. Oh, lunch लिया है. आपके पास आधे time of lunch. No, time of lunch.
Already finished करके आ रहा हूँ. Yes, okay. Good morning to all. Nandra Verma, and I'm from Rajaramani Center for Advanced Technology. The title of this paper is the lightweight reusable model for real-time fire and smoke detection in the footage. Outline of presentation, motivational and problem statement, objectives and contribution. What are the data set that could be used in this paper? Proposed model architecture, experiment results, and comparison of our results with existing leading studies, and finally conclusion. So the motivation behind this work is the fire accidents poses serious risk, global risk. According to a survey which was conducted on the Indian hospital from 2010 to 19, it was found that most of the accidents were due to ACs. Okay. So एक सर्वे हमने पेपर में इंक्लूड किया था जिसमें ये पाया गया कि जितने भी एक्सीडेंट्स होते हैं हॉस्पिटल्स में वो एसीज की वजह से होते हैं. तो अगर ऐसे सिस्टम्स में if we employ such systems which can visually detect the fire or smoke, so such accidents would be reduced to a very great extent. Limitation of traditional system जो कि सेंसर बेस्ड सिस्टम्स होते हैं they are generally false alarms क्योंकि वहां पे डस्ट पार्टिकल भी गई तो वो फायर को डिटेक्ट करता है. Similarly, they suffer from the delayed responses. So in addition to improve such system, this हमारा जो system है एक assistive system की तरह काम करेगा. It is not the replacement of the sensor system. Valuable. So the model that we designed is the lightweight. It is based on the efficient net-based model, and it can be easily deployed over the computationally low devices. So, for example, Raspberry Pi, AI modules, Jetson Nano, NVIDIA Jetson Nano, and other small devices. So this is the data set that we use in our work. So the total of 18,000 plus images were used for the training the model. The data set is taken from the variant sources including the Kaggle, RoboFlow, Bowfire, FireNet, and Google Images. And this is the classification task in which we classified the fire and smoke images from the normal ones. The training and testing speed is 80-20 ratio. Similarly, we have evaluated our model on the variety of benchmark dataset, including the Bluefire, FireNet, and CAIR datasets. These are the well-known datasets which are used for benchmarking the fire smoke models. This is the distribution of a database across. For example, we have taken the 9,000 plus images of the fire smoke and 3,000 plus images of normal. Similarly, from the cable, Bowfire, FireNet, and Google. So first graph shows the distribution of training sets across fire and normal images. Similarly, the second graph shows
lightweight
number of images.
सर भी फायर स्मोक डिटेक्शन अभी सर ये
evaluating the data set.
मोड है मैथमेटिक सर भी काफी सारे हैं
अभी पार्टिसिपेंट हैं अवेलेबल
सर ऑनलाइन में अगर वो ज्वाइन करते हैं
ऑनलाइन बहुत सारे स्क्रीन बड़ा पे
स्क्रीन व्हाट इस पे ही है
Yes. So this is the data set, and this is our proposed model architecture. So the model takes the input 224 cross 224 images as input, and as a base model, we have taken the efficient net V0 as the base for the feature extractor, and additionally we added some custom layer as a classifier for fire and non-fire images. And finally, the model will tell that the given input is fire or non-fire image. Simply, it is the binary classification problem. And these are the key parameters of our model. The base architecture is efficient at P0, which is pre-trained on the imaginary data set. We added some custom layers in order to work with our data set. Image size is 224 cross 224. Learning rate, training size, and we train our model from 16 to 50 epochs. And the training platform is we train our model on the high performance computing cluster Kshitish 5, which is located in the Rajaramana Center for Advanced Technology. We use the GPU node of this cluster to train our model, and it took around 3 to 4 hours to get completely train our model. This node contains the two NVIDIA Tesla P100 GPUs. This is the training, for training, it is the accuracy and validation graphs. We can see from the graphs, after certain epochs, say from 40 to 50, 60 epochs, the model was become quite steady. After that, further training, we found that there is no further improvement in the model. So we stopped the training there only after 60 epochs. Similarly, the loss graph can be seen after same number of epochs, the loss could not reduce further. After completely training the model, we converted the weights of the model to TensorFlow Lite to further optimize the model to be deployed on the edge devices. Because after training जो model का जो size था वो around 21 MB था, और उसको TensorFlow Lite में convert करने के बाद we could be able to reduce the model to the 10 MB so that it can be easily deployed on the edge devices. So these are the results that we achieved. On the Bowfire benchmark dataset, we achieved the 90% accuracy, precision of 0.91 precision, 90 recall, 0.90 FN score, and 0.97 AUC score for the Bowfire dataset. And this dataset contains total of the 226 images, out of which normal images are 103 and 123 images belong to fire smoke class. Similarly, for the FireNet dataset, we could achieve the 96% of the accuracy. Similarly, 0.97 precision, 0.96 recall, 0.96 FN score, and 0.99 AUC score, and the total images were 195. So this way we can conclude, I can conclude that the models, the results of that we achieved are quite encouraging. These are the AU ROC graphs for all benchmark dataset. From the curve of the graph, we can easily conclude that results are quite encouraging. This is the confusion matrix for all four benchmark datasets. If we evaluate the first one, which is the 82 plus 21, so total 103 images are there, out of which 82 जो है वो नॉन फायर क्लास की है, जिसमें हमारा मॉडल मतलब 103 में से 82 इमेजेस को हमारा जो मॉडल है नॉन फायर क्लासिफाई कर पाया, एंड रेस्ट 21 के लिए फॉल्स पॉजिटिव हो गया. सिमिलरली जो 123 टोटल इमेजेस थी फायर स्मोक क्लासेस की, जिसमें से सिर्फ 2 इमेजेस के लिए हमारा मॉडल जो है फॉल्स नेगेटिव हुआ कि 121 इमेजेस को उसने करेक्टली आइडेंटिफाई कर पाया. Similarly, for the other data sets, confusion matrices are depicted here. So our result is the model was converted to TensorFlow Lite format for optimized edge device uses, and we after real-time deployment, the model was able to achieve the 12 frame per seconds. तो जब हम वीडियो इनपुट फील्ड में देखते हैं तो मॉडल्स को 12 फ्रेम पर सेकंड्स पे प्रोसेस कर पाता है ऑन द एज डिवाइस रास्पबेरी पाई हैविंग द 4 GB ऑफ मेमोरी.
Okay, so listen again हमारे ये मनोज पटेल से मुझे कुछ हिस्सा.
These are the comparison of our results with the other leading studies. For example, the first row shows our own results. Second row shows the exception model, which took the training images, 5,000 plus images. Benchmark set was Bowfire, and their accuracy was 91%. Okay, but this model is limited for computationally demand. Means ये lightweight model नहीं है. Similarly, BCFS Bowfire dataset benchmarking के लिए है 88% accuracy they achieve. Similarly, other models are also listed. तो यहाँ पे डिफरेंस ये कि हमने जो मल्टीपल बेंचमार्क डेटा सेट को कवर किया है टू कवर द वेराइटी ऑफ इमेजेस फ्रॉम द स्मॉल फायर टू मीडियम फायर एंड डिफरेंट टाइप्स ऑफ स्मोक. हम हर प्रकार के केस को हम कवर कर पाए. तो हमने वेराइटी ऑफ ट्रेनिंग सेट में भी हमने वेराइटी ऑफ डेटा सेट्स को इंक्लूड किया है, एंड बेंचमार्किंग के लिए भी हमने मल्टीपल डेटा सेट्स के ऊपर मॉडल की बेंचमार्किंग परफॉर्म की. So these are the key insights of our work. Optimal generalization, the efficient net B0 model achieved a satisfactory accuracy that we have already seen, precision and recall across multiple benchmark data sets, demonstrating its effectiveness in diverse fire and smoke detection scenarios. क्योंकि जो डेटा सेट है उसमें हमने डिफरेंट टाइप के सिनेरियोस से कवर किया. ऑफिस फायर्स हो गया, प्लेग्राउंड्स हो गया, फॉरेस्ट हो गया, तो जितने भी टाइप की फायर्स के सिनेरियोस है सभी को हमने कवर करने की कोशिश की है थ्रू डिफरेंट डेटा सेट्स. दिस इज द लाइटवेट. The model's lightweight design makes it well suited for deployment on cost-effective embedded systems like Raspberry Pi or NVIDIA Jetson Nano devices. The edge deployability, similarly real-time performance है कि with this model we are able to achieve the 12 frames per second on the Raspberry Pi 4 devices. And it is the valuable supplement actually. We are not saying कि हम existing जो सेंसर बेस्ड जो सॉल्यूशंस है उनको हम रिप्लेस कर रहे हैं, बट दिस इज द वेरिएबल सप्लीमेंट टू द एक्जिस्टिंग सिस्टम।
आते हो खाना खाते हो फिर मैं जाऊंगा।
These are the specific future directions of our work. The future research will focus on the integrating state-of-the-art object detection model. Although हमने इस same work को हमने object detection YOLO V11 model के through भी किया हुआ है already. This is our initial work, इसलिए paper में हमने इसको present किया है. And the next specific future direction is integration of the thermal data from infrared cameras with visual data. Next हम क्या करेंगे कि जो हीट डेटा है उसको हम इमेजेस के साथ क्लब करके मॉडल को ट्रेन करने की कोशिश करेंगे। दिस फ्यूजन अप्रोच इज एक्सपेक्टेड टू एक्यूरेटली आइडेंटिफाई हीट एनोमलीज इवन इन द लो विजिबिलिटी एंड प्री कंबशन सिनेरियोस। मींस ऐसे सिनेरियो जहां पे कि डार्क रूम है और जहां पे स्मोक उठ रहा है, वहां पे हम इंफ्रारेड के जो टेम्परेचर थर्मल डेटा है उसकी यूज के थ्रू हम बिफोर इग्निशन हम ऐसे केसेस को भी फाइंड आउट करने की कोशिश करेंगे। थैंक यू।
Model.
Efficient and P0 model.
Not given any mathematical model here.
No, it is pre-trained on the imaginary data set. When we further optimize this model on our data set. Data, we have taken the data from the 5 different sources. हमने overflow से data set collect किया है, Google Images, Bofire, Firenet, तो 5-6 डेटा सेट से हमने अलग अलग डेटा सेट से इमेजेस को कलेक्ट करके टोटल 18,000 इमेजेस का हमारा डेटा सेट है।
Analysis is there. You have to
training for training purpose, for training only, training plus validation.
What is the references? You are collecting from where you have to collect these data and there is no reference between them.
Actually, references are listed in the paper, but I can show you the specific sources of the data. See, the second line shows the diverse sources. Data was collected from the multiple public data set. All the data image data set is a public data set, open available, including the Kaggle. It is the data का जो platforms है, यहाँ पे variety of data sets are available already, which are publicly for research and study work. Overflow, it is again the platform for data set. Yeah, I have included the sources of data. Actually, the author published, they collect the images and publish the data set. So, वहाँ पे वही data set है this. Similarly, Bofire, Firenet जो है वो तो benchmark data set से है। तो उनके भी जो training set है उनको भी हमने include किया है training system.
ये बता दो।
Yeah.
Where is there any difficulties? As we told that for big data, large data, there is a limitation.
उसकी बैटरी खत्म।
So what is the size of the data?
Size of the data set we have taken 224 grams, 224 images.
बैटरी हैंड की
Size है वो 224 है। This size 224 grams, 224 जो कि जो मॉडल है वो इनपुट ही लेता है उस साइज। तो ये हमारी इमेज का साइज था जो टोटल 1000 प्लस इमेजेस which are from training on.
How sensitivity is?
Sensitivity is more than 0.91.
बैच के बाद भी है कितना कितना के बाद कितना
3-4% हो जाना है।
यहाँ प्लस के लिए एग्जैक्ट क्या है सारे रिजल्ट्स को
यानी कि ट्रेक बस
this is the recall is the sensitivity 0.90 sensitivity pilot model pilot data set के लिए 0.96 और के लिए 0.95 और हमारा एंड आउट टेस्ट सेट है जिसमें हमने जितने भी डेटा सेट से उनसे 20% कलेक्ट कर करके अलग अलग टेस्ट सेट बनाया टोटल 3000 प्लस इमेजेस लास्ट तो 3870 इमेजेस से हमारा खुद का बनाया हुआ टेस्ट सेट है जिसके ऊपर हमारे मॉडल ने सेंसिटिविटी ऑफ 0.99 सेंसिटिविटी स्कोर किया है।
So you are getting some tensor flow input.
यस ये फ्लाइट में क्या होता है सर कि जो हमारे मॉडल का जो साइज है जो वेट्स आते हैं मॉडल के इट इज अराउंड 21 MB जो एफिशिएंट नेट के ट्रेनिंग होने के बाद जो वेट्स हैं दे आर मैथमेटिकल तो ऐसे वेट को अगर हम एज डिवाइस पे डिफाइन करेंगे तो इट इज कंप्यूटेशनली हैवी ज्यादा मेमोरी ऑक्यूपाई करेगा कंप्यूटेशंस भी ज्यादा होंगे तो इस तरह के मॉडल को अगर हमें एज डिवाइस पे डिप्लॉय करना है तो वी नीड टू कन्वर्ट और ऑप्टिमाइज द मॉडल विद स्मॉलर साइज ये क्या करता है ये जो मॉडल के जो वेट्स हैं 32 बिट्स नंबर है इनको 8 बिट या 16 बिट इंटीजर में कन्वर्ट कर देता है सो दैट दिस वेट्स कैन बी इजीली डिप्लॉयड ऑन द एज डिवाइसेस तो वहां पे कंप्यूटेशनली कॉस्ट भी कम हो जाएगी और मेमोरी रिक्वायरमेंट भी काफी रिड्यूस हो जाएगी सो दैट यू कैन डिप्लॉय on the edge devices like the Raspberry Pi, NVIDIA Jetson Nano, or other embedded devices.
Is there any how is there any algorithm you are making that transfer?
No, it is that we can again we can lifestyle in which we just input our weights and it will
पूछ रहा हूँ
there is no
पिक्चर अवेलेबल कर देते हैं गलती से मतलब गलती ऐसी है कि मतलब गलती जो भी है सारी मेरे पे है कि नहीं ये शुद्ध ये बंदा बढ़ना ये कम
That's right.
बार बार मैसेज बटन को कर देने का खराब करेगा
Now, you can get application, there are a lot of things happening. You have about the sensitivity of the problem. So that the present algorithm may not work in some of the problems. So, for example, if you the size is more, and you cannot be back to the present, there will be some problem in the algorithm. So you can check that. So one can improve that kind of algorithm.
डेफिनेटली सर हमारे मॉडल का ये है कि जो डार्क रूम के अंदर में स्मोक है तो वहां पे इट विल फेल सो दैट्स व्हाई वी आर ट्राइंग टू इनकॉर्पोरेट द हीट ऑफ द थर्मल डेटा फ्रॉम द इंफ्रारेड कैमरास तो इमेज डेटा प्लस थर्मल डेटा को कंबाइन करके जब मॉडल ट्रेन होगा तो इट विल बी एबल टू आइडेंटिफाई द स्मोक इन द डार्क रूम
तुम्हारी हाइट छोटी कैसे हो गई
ओके थैंक यू वेरी मच
ये है सर प्रेजेंटेशन उसके बाद में है प्रेजेंटेशन जा जा जा
Thank you, sir. That presentation truly brought us to think through new perspectives. That brings us to the end of this session. Thank you to all the presenters and a huge thank you to our session chairs, Professor Manoj Patel and Dr. Ajay Buchi. I sincerely thank all the speakers for sharing their truly inspiring ideas and themes. I now request everyone to move to Auditorium 2 for lunch break. You are all requested to arrive back at the auditorium at 2 p.m. for the rest of the presentation. Thank you.
तो पता है it's okay but the thing is your English is good and this is the most हाँ भैया बोलो आ गए आ गए आ गए आ गए आ गए सर सर्टिफिकेट अभी आपको 4:30 के अप्रॉक्स मिलेगा ओके और एक बार रिक्वेस्ट थी कि जो पेपर का जो एब्स्ट्रैक्ट है ना जो बुकलेट है उससे मेरा जो ऑफिशियल ईमेल आईडी नहीं जीमेल वाला डाल दिया तो उसके लिए किनसे बात कर सकते हैं सर उसके लिए आपको ममता नाम से बात करनी पड़ेगी ओके अगर वो आएंगे तो बताएंगे श्योर सर Me came as why the fuck are you here? Just go and eat your lunch. I was about to hit him with this. But should we go to the numbers?
back in it. ओके प्रेजेंटेशन रुकी नहीं है
अच्छा हाँ प्रेजेंटेशन रुकी नहीं है वाला कहीं बना जा
Are you able to hear me?
Yes, sir, we are able to hear you.
Okay, yeah. So, shall I start now? In the presentation, I think you need to allow me presentation mode. Share the window. Yeah. Are you able to see my presentation? Yes. Shall I start now? Hello. I can't hear anything.
So
Yeah.
we were slowly.
Dr. Krishna,
Yeah.
can you hear me?
Absolutely. Yeah.
No,
I'm able.
you are unmuted. Please. Yeah, you are muted. Please unmute.
Is better now?
नहीं आ रही है उनकी तरफ से.
Is okay now?
No, unmute. Yeah,
I'm not in unmute from my side.
hello.
Yeah.
Please unmute.
Unmute. Yeah.
Sir, he's unmuted. I don't know why.
Okay, I'm unmute now. Yeah. Are you able to hear me? What I will do, I'll stop presenting and then I will see the audio first. Yeah. Are you able to hear me? Yeah. You know, in the conference says that you are unmute. That's the main point.
यहाँ पे आ रही है। यहाँ पे आ रही है।
My side, I'm not on mute. Do you ask me to join again? I can join. Give me 1 minute. Yeah. How about now? I can't hear from your side.
Go ahead.
I'm able to hear now.
Yeah.
Okay. Let me start the presentation. Are you able to see?
Yes.
Yes?
Yeah, yeah.
Okay.
Please go ahead.
Okay. Shall I start now?
Yeah.
Okay. Good afternoon, professors and research scholars, and thank you for inviting me for this prestigious fourth international conference on recent trends in advanced sciences and computing, which is organized and combined with the IIT Bhopal as well, Indore as well as the VIT. Thanks for inviting me for this. Expert talk on advanced scientific computing. Myself is Dr. Krishna. You can find me in LinkedIn. I will share my profile later on. So let's concentrate on the artificial intelligence powered digital transformation and beyond. What is really does matter for us in terms of the combining the three pillars together. So what is that important is the convergence, the word convergence of artificial intelligence, quantum computing, and scientific research for a sustainable planet, so that the outcome of the solution will give us the human beings in the planet is healthy living and health for the healthy planet. These are all very important research. And then recent world economic forum projected that trillions of dollars are spending in R&D combined with three pillars. So what the today agenda is to about the introduction of the my expert talk on this sustainable planet, uh, and then three pillars of AI powered digital transformation and beyond. And then what is that AI engine for scientific discovery, quantum computing and hybrid science, scientific research breakthrough, and finally the engine of all three pillars integrated to make us more solutions, complex solution to be solvable by using three pillars. So which is data, knowledge, and innovation. And then the evidence supports the case studies which is being conducted by various prestigious organizations. And then investment opportunities, which is very important all of us to get motivation and then mindset all together to provide a complex solution in a simple way. Yeah. So what does it means? We stand at the convergence of artificial intelligence, quantum computing, and scientific research. The word I'm stressing again in this expert talk is convergence. So what is really matter for us? So the matter for that is evolving a new frontiers, sustainable solution for resilient, thriving planet. Example, climate change, resource depletion, energy demand, food insecurity, and global health risks are accelerating. We are all facing nowadays the burning issues across the globe. And then what the traditional approaches, what we are moving, transforming to in a quantum approach. Okay, so that's what the all together AI together with the quantum, and then together with the research findings, that's the evidence of what we are here today. Scientific research is not the future dream, it is an urgent present day opportunities to redesign how the world works. That's the message. Why the urgency is so important? The sustainable development goals are behind schedule. Only a minority of sustainable development goals targets are on track. Why? That is, we will go through the subsequent slides. And planetary challenges are accelerating. We need approaches that are faster, more integrated, and evidence based. The evidence based is justifiable the scientific research, and integrated tools. We have to understand all the three pillars. Now, this is the next important aspect of AI powered digital transformation. If you look into the left side, three spheres. One is artificial intelligence, the another left side is quantum computing, and the right side is scientific research. Big. So all three together is combined together. You have a Venn diagram where the union of the three areas will be triggered as a data and knowledge that leads to a in a different challenges to be solved in a sustainable way. 1 minute here. So I'm in a call, Professor. I'm in a video call, conference call. You can join. Yeah. Okay.
I'm trying, but unless they allow.
Okay. Yeah, I think the Professor Chaitanya ji is unable to join. Could you accept the host to him? Yeah. Okay. Sorry for that. So each one, if you look at these three pillars, each one contributes a different type of intelligence, capabilities, and insights. So when they interact, they create an exponentially stronger ecosystems leading to a sustainability. Like for example, climate change or a, power optimization solutions for the national grids. So a lot of things like a discovery, drug discoveries. These are all the main important of engine. The core engine is data and the knowledge and innovation will be outcome, the solution of this all three sphere, if you look at the spheres of artificial intelligence, quantum computing, and scientific research, the outcome is a sustainable solution for the healthy living and the healthy planet. Okay. So I don't want to give a school definition or a college or university definition. You're all there at the table. So we have all come across this. So what is the outcome is data and the knowledge. So the core of AI, quantum computing capabilities will be evidenced based on the scientific research breakthroughs. Okay. So what is this combined together? If you look at the artificial intelligence and the quantum computing, what it leads to us together is an advanced AI models is innovating. And then when you combine the another pillar of quantum computing, artificial intelligence, scientific research, what it does, it gives an applied innovations and then models, and then quantum computer and scientific research together will make a scientific breakthrough. That is the trial of all the pillars of we need to think about as a scientific community all together here. So when you say artificial intelligence and quantum computing will together lead to an advanced AI models, the models AI is a fundamental models to be an advanced to solve the complex problems, and then it is far more efficient, that is important, and more accurate, because now the trust of the AI is adopting by the industries still lacking the trust. That's the reason they are not adopted in so many of their respective departments of individual organizations or the government agencies. So next one is artificial intelligence and scientific research. If you look at these two spheres combined together makes an applied innovations like automating discovery, optimizing processes, enabling rapid prototyping. Rapid prototyping, the word I'm using is because of the competitive advantages and getting the business more a meaningful solution to the end user. So we have to think about. Next, the scaling insights globally. The quantum computing will give a scaling, though it's in early stage, but it gives a more meaningful and fruitful results. Then quantum computing together with the scientific researchers, that's what we are here to understand the new scientific breakthroughs. For example, drug discovery is associated to an individual patient, and material sciences, energy storage, atmospheric physics, so many. Yep, it will influences the planet healthy. All three combined together will make an entire ecosystem is more friendly to solve the complex problems. So that leads to a data plus knowledge fusion enables real-time decision making. Predictive system, the current systems of machine learning alone can't be solved the predictive model. Those accuracy or precision may be a little bit far behind. That was the reason the trust of using AI adopting in a respective departments is still reluctant, though it is in a upward trend. So the main focus of today's lecture is about the three pillars combined together, integrated to make a scientific breakthroughs. Okay, now why this convergence mattered now? For the first time ever, AI can talk. We have already seen the chat GPTs and Copilot and all. AI can talk, or the robotics can feel that. Next, using the quantum computers can simulate the nature, and digital twins can model the entire planet. Then obviously the scientific research is becoming autonomous. This convergence is not limited to the one country at all. It is a global transformation touching every continent, every discipline, and every industry. What it leads to us, the future of science is open, accelerated, intelligent, and sustainable, because it's open research, because you got the data sets from across the world. The researchers are working on it. Now the science is advancing into so fast compared to the 20 years ago or 10 years ago, that science is open, accelerated, intelligent, and sustainable. So I will give the evidence in terms of the millions of publications are happening in the day-to-day and the yearly basis and monthly basis. So what are the qualities of research papers are coming together, how that lead to be, a wealthy planet for the healthy livings for us. Okay. Now, if you look at the first pillar of the AI, if you look at the first pillar of the sphere of the AI, artificial intelligence, second is the quantum and scientific research. All three we will go slowly. So what is that AI? AI, artificial intelligence, as the engine of scientific discovery. We have seen now all the challenges for an academics or an industry, the low code and more focus on the business insights. getting the more business friendly and user friendly. So AI is become a co-scientist now because the research reads millions of papers and generates hypotheses, runs simulations, designs experiments, writes draft of scientific reports. So this is happening at whether it's a DeepMind or MIT or Stanford, this is happening, co-pilot, co-scientist. Similarly, tutoring, co-tutoring. So if you give an assignment to the student, they're saying, no, I'll take advice from the co-pilot. This is a kind of situation, how to challenge that, how to make it a more meaningful contribution. So next one is about the scientific domains transformation by the AI. So we have come across all the different disciplines in the academic disciplines. Biology, we have seen that AI predictive model structures, drug interaction, protein dynamics, we have seen in coronavirus time. Chemistry, that's also very important thing. Robotic chemist runs 24 by 7, discovering new materials like UK and China is experimenting. Rather than scientists can invent the new element in the on the Earth, like space science. AI detects exoplanet faster than astronomers. So these are all the things are evolving. So and also medicines, we have seen that different type of drug discovery is happening. Mathematics is another important area. Deep minds, alpha tensor and alpha geometry are discovering new mathematical algorithms. No need, they are not waiting for the scientists to discover the new model algorithms. This is what is happening for challenges for everyone. So what are the things we have to bring together as a single entity? So now when you see the research opportunities with AI driven material discovery, simulation based climate models, so many things are happening in that day to day. Now when the opportunities for startup, I came up with together is an idea of research opportunities and startup opportunities.
It's more.
Yeah, sorry.
7 minutes more.
Sorry?
7 minutes. 7 minutes.
Yeah, that's fine. Yeah. Now we are going to the quantum computing and hybrid science. The quantum computing, when you see that ultra efficient batteries, carbon capture materials, and green catalysts are happening in that. Yeah. So what is that quantum computing computers bringing together? Because it's optimization problems impossible for classical computers. That's what now it's though in early stage, but it break through the lot of complex solutions into a soluble solutions. Yeah. Why the quantum matters globally? Because it's simulating molecules at atomic precision, designing future batteries, so on and so on. Yeah. Now, when you say that the opportunities, again, I'm discussing research opportunities. We have a machine learning, which is solving in a classical computing. Now, quantum machine learning, quantum neural networks. These are either additional opportunities for all the research scholars, PhDs, and funded projects. We can do that. So these opportunities also funded by the global quantum race. US, China, Japan, everyone is doing it. Yeah. Okay, now the scientific research sphere, which is very important for us, the key scientific contributions, what is a credible truth without which AI and quantum cannot be trusted? That is important, remember, they are all the tools to justify your research findings. So these are all the scientific research one. When you say the different global organizations, NASA and all, they come up with digital twins labs. So digital twins will save millions of lives through predictions and preventions. Okay, now when you look at the global research areas, you have every areas like AI-driven material discovery, quantum chemistry simulation, climate tech twins, and the startup opportunities. It reaches each and every, like for example, climate risk intelligence system. If you develop, it's a 1 billion minimum dollars opportunity, market opportunity, and also energy grid optimization as software as a solution. So a lot of things we can bring together using this integrated approach. So autonomous scientific labs is happening, energy grid optimization is happening, biotech AI is, these are all various ways of doing it. Now, as I said, all the three, like AI, quantum, and scientific research, three pillars makes an integrated approach of data, knowledge, and innovation. So AI, this is what is happening nowadays. That is what is important of the idea to become a prototype. That prototype will be a global impact in an upscale and sustainable planet. Okay. Now, when you say real world sustainable outcome, sustainable energy systems we can develop using carbon neutral intelligence energy ecosystems we can develop using the AI, quantum, and science one. Similarly, we can do so many areas, agriculture and food security. Similarly, we can do that. I can go through that, the one case study, which is really useful to all of us. Similarly, we have the, what is the final outcome of this, the three pillars integrated together as a, scientific breakthrough. The final outcome is very simple: a sustainable planet to brings the sustainable solution. So what it's not technology alone. I said it's a synergy. It intelligent decision system. We can make it breakthrough materials, climate smart infrastructure, resilient ecosystems, equitable access to global resources, and a blueprint for planetary stewardship. This is what is the ethic. The convergence is not just a technical; it is an ethical, strategic, and a global solution. Why the final outcome is a sustainable solution? Because the sustainability requires complex cross-disciplinary innovation, something no single field can achieve alone. So scalability means AI scales insights globally in real time. Scientifically validated research ensures that credibility and evidence. Computation ready for planetary systems. Quantum allows modeling of climate, oceans, energy ecosystems. Data driven and continuously learning. The data and knowledge core ensure solutions evolve and improve. This is what is the final intelligence of systems we can develop. What we stand for is a dawn of new scientific age. This is what AI intelligence system and quantum capabilities and leverage the science evidence based guidance all make you a meaningful ecosystem we can develop, and which the future of science is nothing but a global collaborative intelligent and open to all. That's open science. And the next breakthrough may come from anyone among us to see that the three pillars combine together. So what is the three pillars if we look at? So what is that we have learned in the today class? Artificial intelligence, quantum computing, and a scientific research together to make a sustainable solution with the data, knowledge, and innovation of research. That's what. And the case study, if you look at what is that interest for us, the case study. If you look at the ecosystem of the energy ecosystem, so problem, grids must manage intermediate renewable and surging demand. What is the convergent solution we will bring together as a AI forecast demand and orchestrate resources, quantum aided materials design improve battery density and longevity. Scientific validation ensures that safety and life cycle benefits. What is that evidence we have based on the prediction of the World Economic Forum is using these three pillars integrated to make a 1.8 gigatons of CO2 reduced. That's a surprising news in the power sector when combined with other interventions. So AI tools across the building and industry can lower CO2 emissions and energy costs for enterprise by up to 10 to 20% in target cases. This is very interesting. So look at the picture of this, how the projections are happening in this was, it's not a joke at all. It's possible together with the quantum capabilities, AI intelligence, and research scientific together make a scientific breakthrough solution. Similarly, we have a carbon removal models and all these models. What I'm interesting here is like agriculture sectors, the precision farming, we can do quality crops and waste management of the products. We can do a lot of things. So I don't want to go through that so much time because we have very less time. What I'm interesting is about the investment opportunities, scale and investment. How big is this? It's a nearly 3 point trillion. The scientific research scale global R&D spending reached roughly 3.03 trillions in recent years, with millions of annual scientific publications is publishing, as I said earlier, an enormous research engine to power applied breakthroughs. So UNESCO dataset shows R&D is already a multi-million dollar global activity combined with the three pillars: AI adoption, quantum capabilities, and scientific research together. So it's a big opportunities for all of us to make a startup or make a research oriented products. That is what is important. So what at the same time our challenge is to get the governance and the risks. We need to understand the standard, transparency, and public private coordination is very important in terms of to successful in order to successful upscaling solutions. What everyone is look like in theory, no, it's a practically we have implemented in a couple of sectors like banking sector, fraud detections, and insurance and all. Now we can use this how to operationalize convergence, the data and knowledge infrastructure, So it has the data in interoperable data sets are happening when the fair principles and secure data sharing is going on. Targeted investment, focus on the sustainable planet solutions like energy, food, security, health, materials, and circular systems. And public-private R&D consortia underway. We can bring together as national quantum hubs, AI for SDGs, and partnerships. Governance and workforce, already I said to you, invest in reskilling, standards, and multi-stakeholder governance. So what happened this all together is, before asking to the questions and I in 2 minutes. So what I wanted to bring this is why it is AI-powered digital transformation and beyond is because of the convergence of artificial intelligence, quantum computing, and scientific research for a sustainable planet, for healthy living and healthy for the healthy planet. This is the unique selling point of how we can make it, because the World Economic Forum is clearly indicated that the sustainable solution goals of each country and each organization, how they can be adopt and transform. So that's an idea of where I came up with this in AI powered digital transformation and beyond to make a sustainable solution for the healthy planet. It's a $1 trillion industry, so we can all can be in a work together or make a projects or a research set together and leverage the quantum capabilities and artificial intelligence solutions and research evidences of what we are today. Okay, that's all today's lesson, though it's a short term. So it's so fast I've gone through in my first time in my in 10 minutes presentation. Any questions and answers? I'm happy to answer.
Thank you very much.
Yeah.
Krishna, if you have any question, now the door is open for audience. If you have any question, please. So I have one question. So as you mentioned that convergence of quantum computing, artificial intelligence, and scientific computing. Okay. So is there any mathematical tools you are developing, or just I don't know, because in your presentation we didn't find some mathematical
Yeah,
objects.
when you look at the let me explain to you this easy way of doing it. You have seen the three pillars, right? When you say the three spheres, the artificial intelligence will come up with mathematical models or a scientific problems. Okay, that mathematical algorithms or the models will leverage the developing of AI models. That's what, yeah. Because the use case, personal use case, I didn't go through that, but that's obviously every artificial intelligence model develop is the behind is in a mathematical or a statistical model. Okay.
Okay, okay, good, good. Thank you so much for wonderful talk. That's a gift.
Thank you all.
Very nice presentation, Dr. Krishna. I'm really delighted that in such a small span of time, you have covered two very important aspects.
Yes, sir.
In particular, the correlation between AI and the quantum computing, if you can take 2 minutes to make us understand better.
Yeah, give me 1 minute, sir. Yeah, so let me go that. So I think you joined a little bit late. Let me explain to you the importance of that. Okay, are you able to see the presentation mode? Are you able to see presentation mode, sir? Yeah.
Yes.
Okay. So when you look into this, artificial intelligence is one sphere, and quantum computer is the another sphere, and then the right side is a scientific research, another sphere. When you look into that, artificial intelligence and the quantum computing will make an advanced AI models, and then artificial intelligence and scientific research, you will get an applied innovation model, so you can develop, and then combined with the quantum computing and scientific research, we can make a scientific breakthrough. This is the next slide. If you look at this will give you an example of, I think my screen is stuck. Give me 1 minute. Yeah, are you able to see? So combined with that, artificial intelligence is the models. All the predictive models are been happening now in across the world, whether it's a GPT or an agent, AI agent, and then quantum computing capabilities, because the precision and recall or the false positive and false negative rates. So if you look at the current artificial intelligence system is far behind because the user trust is lost because of the bias and hallucination. So obviously, we need to have the leverage the quantum computing capabilities to bring together, make a more advanced AI models. Then the combined of quantum computing, artificial intelligence research, scientific research combined together, we can make an applied innovations, because you are playing within a models, applied models, your scientific research, and then artificial intelligence, your the algorithms. So that makes an applied innovation. Now, the together with quantum computing and the scientific research, that's a scientific breakthrough. That's what is happening, because you are getting a more accurate solutions and less error prone. Yeah. So this is what is the quantum computing and research together to make a scientific breakthrough. We have gone through the the drug discovery for an patients specific, or the climate change, or the finding the new elements on the earth. So this is what the combined together, because the quantum computing is it's different from the classical computing. Obviously, the most complex solutions can be solved. Yeah. So combined together, all three combined space together is an engine, is nothing but your data, knowledge, and innovation. That engine will make a sustainable solution for the a healthy living planet for the healthy lives. That's the message. Okay.
Wonderful.
This
Wonderful.
opens
Excellent.
this opens a trillions of billion industry. And the use cases are like, for example, the pollutions in the traffic management, asset management systems, or the smart cities, or the waste management in the agriculture. Yeah. So CO2 emission.
Can you hear me?
Yeah.
Yeah, our next speaker is waiting. So please make it short.
Yeah. All done. Any more questions, sir? Anyone?
We are truly honored that you took the time of your incredibly busy schedule to share your expertise and passion with our audience. Also, a sincere thank you to our session chair, Dr. Shakti Kat. It is my great pleasure to introduce our next keynote speaker, a true authority in her field, Professor Arjun Mary. Professor Arjun is a distinguished scholar specialized in associative algebra. With over 20 years of experience in both teaching and research, he has made significant contributions to the academic world. I would also like to invite Professor Manoj Patel as the next session chair. Please join me in giving a very warm welcome to Professor Arjun. Since we are running out of time, we sincerely request you, Professor, please do limit your lecture to only 50 minutes.
Good afternoon. Am I audible?
Yes, you're audible, sir.
Yes, yes. Actually, due to the start of the time, we are I'll reduce your time, sir. So within 20 minutes, if possible, then you have to finish.
Okay, sure.
Okay,
Yes,
please.
right.
Yeah, try to
Thank you
share.
so much.
Yeah,
All right.
it's visible. Try to, yeah, continue.
Okay, thank you. So, thank you. I'd like to thank the organizers for allowing me to give my talk on generalizations of semi-commutativity. I hope you can see my screen.
Yes.
Yes, we
Yes.
can.
Okay, thank
Yes,
you so much.
yes, please continue.
Yes. So I will not take much time. Let me straight away go to the notion of semi-commutativity. So a ring is called semi-commutative if whenever the product of two elements is zero, you can insert an element in between and get it to be zero again. So it is called semi-commutative because it includes the class of commutative rings. And this class of rings have been also called as insertion of factors property or the zero insertive because you can insert a point in between. The name was coined by Narbonne and it was carried out in detail by Shin in his paper, Prime Ideals and Sheaf Representation of a Pseudosymmetric Ring. So we note that the left annihilator and the right annihilator of elements are two-sided ideals of the ring. Now, with the advent of semi-commutative rings, there are various generalizations. One was by Chen in 2003, another one by Mohammadi 2012, and again by Mohammadi in 2012. Recently, me and my research scholar, we thought that why not introduce a class of generalizations of semi-competitivity. We called the class to be weakly nil semi-competitive rings, in short, WNSC. And also, we also introduced another class known as point-wise semi-competitive rings, so which I'm going to present to you in my next slide. So a ring is called weakly nil semi-commutative. As I mentioned, in 2023, we introduced this notion that whenever you take elements from the set of nilpotent elements of the ring, whenever the product is zero, you can insert anywhere anything in between to get the element to be nilpotent. So it has been observed that this contains the class of reduced rings, and it's closed under subrings and direct products. And the various relations is this. So you have a weakly nil semi-commutative, which includes all these notions which are introduced before. And if you let NR denote the set of nilpotent elements, and if it happens that the set of nilpotent elements is an ideal, then the ring turns out to be weakly nil semi-commutative. And these are two results which involves quotients. If the quotient is WNSC and if the ideal is reduced, then the ring itself is WNSC. And also, if you take the prime radical of the ring, which is the intersection of all the prime ideals of R, and if it happens that the quotient ring R by PR is WNSC, then the ring is WNSC. So another question is, when will the four or the five concepts coincide? So it happens that if you have the set of all zero devices, if that set is reduced, then if it is reduced, then all the notions they coincide. And this is one example, namely the matrices over the field Z2, that is WNSC. And however, if you take n greater than equal to 3, then it fails to be WNSC because of this reason that you have EN2 and E1n, the product is 0. Whereas if you insert anything in between, then there are elements which doesn't lie in the set of nilpotent elements. So we found out that the localization by central regular elements, that is WNSC again. So the localization is preserved. And the Nagata extension, that also is preserved under this property of WNSC. And also for Doro extension, we have this result that the nilpotent elements, they have this formula. And because of this, you get that the Doro extension is also preserved under this property of WNSC rings. And then moving on to the Morita context, we have that if R and S are two rings, and M is an RS bimodule, N is an SR bimodule, then this ring, the matrix ring, it is WNSC if and only if both the diagonal rings R and S are WNSC. But in this case, the Morita context should be with zero pairings. So this is what we have as a corollary. And similarly, for the trivial extension, it is preserved. However, if you do not take zero pairings, then they may fail to hold. The Morita context may fail to hold. So this is the summary of what I have found regarding WNSC. And moving on to another direction, we have the class of pointwise semi-competitive rings, whose definition is this, that a ring is pointwise semi-competitive if either the left annihilator or the right annihilator of an element is an ideal. So this is an example of pointwise semi-competitive, which is not semi-competitive. And it is found out that it is closed under central localizations. It is preserved. However, if you take matrices of these types, then it may not hold. That means WNSC may not carry over. So then we have this notion of Ni ring, namely that the set of nilpotent elements is two-sided ideals. A generalization of this is this class of NCI rings. So it is found out that if a ring is pointwise semi-commutative, then it is NCI. So now we want to show that under what condition will a pointwise semi-commutative ring be Ni? So we found out that there is a notion of rings known as semi-periodic, which was introduced by Bell and Yakub. And under this assumption, you get that the ring is Ni, which gives us that if a ring is semi-periodic and if it is pointwise semi-commutative, then it is WNSC. And the conclusion is this. And the conclusion is also that both the notions of pointwise semi-commutative rings and WNSC rings are closed under central localizations. So these are the references. And thank you so much for your attention.
Wonderful. So you have finished within time. So here is any question or comment from the audience side? Okay, so ma'am, from my side, is here you have to present the hierarchy, means implication. So nil competitive, semi-competitive.
Right.
So that one you have written WNSC is the proper generalization of the ENSC.
Right, right.
Could you provide any counter example which is not true? Means which is WNSC but not NSC?
Okay.
Yeah,
Which is the yeah. So this is one example. Okay, if you take the full matrix rings over Z2, so this is WNSC but not semi-competitive.
It is already.
Yes.
Yes. Thank you very much. Yeah.
Okay, thank you.
So just give the big hand the next thing. Yes, thank you very much.
Okay, thank you.
A huge thank you to Professor Arnold Mary for her outstanding keynote and our sincere appreciation to Professor Manoj Patel for expertly chairing this enlightening session. And with that, we now come to an end of a highly successful keynote session. I want to extend a huge thank you to all the distinguished speakers for today who shared their valuable expertise and insights with us. I must also sincerely extend my deepest gratitude to Dr. Shafiq Ahmed and Dr. Mamta Agarwal for their incredible planning and education.
अभी कान का हुआ था
Best job. Thank you.
सेकंड डे वो उसका हुआ था क्या जाती होगा सर वो दोनों को पीपीटी ना मैं तुम शेयर कर दो सर अगर मेरे पे होगा तो आई विल मैंने तुम्हारे को व्हाट्सएप शेयर किया था ना हाँ जी सर तुम्हारे डेस्कटॉप पे तुमने डाउनलोड किया मैंने फोल्डर बनाया ना डिवाइस लाइक डिवाइस नहीं बनाया क्या
सर वो फर्स्ट डे पे तो सर दूसरे लैपटॉप में था, सेकंड डे मेरे पे है, एंड दिस वर ऑल द प्रेजेंटेशंस जो मुझे मिली सर। एंड सर लाइक देयर वाज सम, मुझे ढूंढना पड़ेगा सर।
तो फोल्डर में जो है ना उसी में देखो, ओपन करके एक पसंद में आए।
श्योर सर। यस सर, क्लीन सर। आपने किन एक बार लिखना मत सर।
वो रतिकांत बेहरा और वो जजाति साहू, ये नहीं है, ये वाला ये नहीं। कौन कौन? ये मतलब ये भी नहीं है, रुको, ये भी नहीं, गोस्वामी भी नहीं, ये पेपर आईडी लिखा है, पेपर आईडी नहीं होगा ये। ये तो मैंने दिया था तुम्हारे से ये मनोज, ये भी नहीं है मतलब। हाँ
जी के
ये है, हाँ ये है।
ओके सर, दिस इज आई विल शेयर इट
हाँ
यू सर।
वो तो तुम बोल रहे थे पहले दिन का है नहीं, फर्स्ट डे का।
फर्स्ट जगह तो सर दूसरे लैपटॉप में, इस वाले लैपटॉप में।
फिर वो जिसको भी है तो फिर वो रतिकांत।
I thank everyone for their patience. We will be starting with validity cells in short.
इसको तो शेयर कर दो तुम अपने व्हाट्सएप से।
सो व्हाट्सएप
है भी
आप नंबर बताओ सर।
नंबर 877
877
077 ये
Anand?
पर नेट चल नहीं रहा है। एक मिनट तो नहीं रहता हूँ। मैं जा नहीं पा रहा है, मेल कर देता हूँ सर।
हाँ मेल कर दो।
समय आएगी।
देखो 3 डॉट से हाँ सब सर का बट ये कितने
सुबह स्कूल में जाना पड़ेगा, जाते हैं मैं
हाँ वो वही है क्या, वही बैठे क्या?
वही उसके साथ जाते हैं, लेके आती हूँ और यही लिस्ट में सर शफीक सर को भी हमको वो करना पड़ेगा।
हाँ
उनका सिलेक्शन
पैसे उठा के तो दे देंगे स्टेज में ही।
स्टेज पे ये देंगे और शफीक से ये देंगे।
कौन देगा?
आप देंगे?
अच्छा ठीक है।
प्लीज ऑफ द कॉन्फ्रेंस।
अरे यार सबको प्रिंसिपल है, कुछ मंदिर में यार
सर लिखना पड़ेगा सर। सर आपको नहीं लिखेंगे तो सर अब
नहीं नहीं कुछ नहीं, तो तुम उससे किससे है उसको किसका है?
वही उसको बोल इधर लैपटॉप निकाल अपना।
कनेक्ट
नहीं कनेक्ट नहीं करना, सर को फाइल चाहिए कुछ। लैपटॉप देख सर आपके पास आ गया होगा। ठीक है, वो रखा है, प्रांशु से पूछ, प्रांशु। तो चेहरा भी दिखाई दिया मेरा भी चाहिए। रेसिस्ट मैम इस बार तो कोई ऑनलाइन प्रेजेंटेशन नहीं है ना अभी।
अब कुछ नहीं है,
इसको
बस
हटवा दो आप,
इसको
ये वाले।
नहीं, ये तो सब लगा होना जरूरी है।
अरे वो पीछे है ना।
मैम पीछे और आगे मैम दोनों सेम ही है एक्चुअली। हाँ मैम
मतलब
पीछे कौन
ये
है
पीछे ये बैक बैक कर दो या तो, एक ही चीज है ना क्योंकि क्या।
ऊपर जाना भाई, ये पीछे रख दे। ऊपर का हो गया पूरा, बैक हो गया ना।
नहीं
प्रेजेंटेशन याद कर रखी है।
सर को ले,
हैं?
सर को ले आए।
हाँ हाँ हाँ, और डेव सर को भी बुलवाना है ना। वो तो मैंने सुना था ना दोनों, ये मेरे फील्ड के है, ये वाला पहले देख।
सर ये मतलब तो मैंने
वर्ड फाइल नहीं थी, वो पीडीएफ फाइल।
प्रेजेंटेशन
उसके बाद ध्यान से हो सकता है। हाँ नहीं चलो ठीक है।
सर वो ऑनलाइन प्रेजेंट कर रहे थे।
नहीं ऑप्शन बस सेकंड टॉपिक था।
इसकी फ्रेंड कहाँ के से कहाँ चला गया भाई ये लैपटॉप इसका तेरी से
डाउनलोड में तो नहीं।
डाउनलोड में पीछे
ना 17 था ना। हाँ
ये ना सर रहने तो मिल गया जो हो गया चाहिए था काम हो गया। पीछे
एक कर दो, तीनों एक साथ उठा दे।
हाँ सर सर वो तो मैं इसमें से नहीं
ठीक है ठीक
तो जीमेल से वीडियो
है। सॉरी ठीक है। सर आ जाइए, आ जाओ तुरंत। नहीं 10 मिनट नहीं, और लेट हो गया है, आप 2 मिनट ले लो। हाँ हाँ 2 मिनट। हाँ Present. We pointer यहीं पे मेरे पैर pointer आपका वहाँ कैमरा पे भी मिल जाएगा नहीं इनके पास फोटो कॉपी में कुछ बोलना तो नहीं आईडी कार्ड आईडी कार्ड तेरे पास ही हाँ कोई दिक्कत नहीं वो तो मेरे पास कॉल है ठीक है क्या बोला इसका आईडी कार्ड जमा दो इसको इधर आईडी कार्ड का फोटो चलो ठीक ठीक है हाँ तो
नीचे सर का बैठो
बोला तो तुमको
आओ ना आओ ना
तो कॉल किए बहुत सारे नहीं सर बट ये तो बोला था तो मैंने तो कॉल किया 10 मिनट बोल रहे मतलब 10 मिनट नहीं 2 मिनट में आओ
कभी कंप्यूटर
Mic's on not still? My mic's on.
सर सिडीन सर
इस बुक है पुराना से
I don't know if it's very comfortable.
हाँ सर आंसर
क्या
स्टार्ट करो समय से
Each and everyone of you. It is with profound sense welcome to school. We extend a heartfelt welcome to the valedictory ceremony of the fourth International Conference on Recent Trends in Advanced Science and Computing, ICRTS 25. This resounding success was made possible through the dedicated efforts of the School of Advanced Science and Languages at VIT Bhopal University, in collaboration with the Indian Institute of Technology in Indore. Along with the generous support of our sponsors, the Anusandhan National Research Foundation, the Council of Scientific and Industrial Research, and our esteemed indexing partners, Scopus and Web of Science. Now we are deeply honored to welcome our distinguished dignitaries on the dais. Our Honorable Chief Guest, Dr. S.K. Varshney, former advisor and head, Department of Science and Technology, Government of India. So kindly come on the stage. Our respected Dean of Faculty Affairs, Dr. Devashi Adhikari sir, the chairperson of the conference and Dean of SASL, Dr. Hemant Kumar Rasheen sir, the Dean of the School of Computing Science and Engineering, Dr. Pushpinder Singh Patija sir, the organizing secretary, Dr. Mamta Agarwal ma'am of VIT Bhopal University, and Professor X.K. Safiq Ahmad sir of IIT Indore. Kindly be present on the stage, sir. We are truly privileged to have with us all our esteemed dignitaries, deans of various schools, director of student welfare, distinguished session speakers, respected faculty members, dedicated researchers, committed organizing committee members, and enthusiastic student participants. Your presence has been the cornerstone of this conference success. Over 3 inspiring days, this conference has served as a dynamic crucible of innovation. We have witnessed the powerful convergence of cutting edge scientific research and transformative computational technologies. And so today, we gather not to commence, but to culminate this. We are here to celebrate the knowledge exchange, the connection nurtured, and the collective achievements of this remarkable assembly. To formally commence this valedictory session, it is my privilege to invite Dr. Dev Mukherjee sir to deliver the welcome address. The stage is yours, sir.
Good afternoon, everyone. Uh, good afternoon, everyone. Respected chief guest of the valedictory season, Dr. S.K. Varshney, former scientist and head, Department of Science and Technology, Government of India, and Honorable Dr. G. Viswanathan, sir, founder and chancellor, VIT. Respected Mr. Shankar Viswanathan, sir, Vice President, VIT Bhopal University. Respected Ms. Kadambari S. Viswanathan, ma'am, Assistant Vice President, VIT Bhopal University. Respected Dr. T.B. Sridharan, sir, Pro Vice Chancellor, VIT Bhopal University. Respected Mr. K.K. Nair, sir, Registrar, VIT Bhopal University. Respected Dr. Devashish Adhikari, sir, Dean Faculty Affairs, VIT Bhopal University. Respected Dr. Hemant Kumar Nashine, sir, Professor and Dean, School of Advanced Sciences and Languages. Respected Dr. Mamta Agarwal, ma'am, Organizing Secretary, ICRTAC 25. Respected Dr. S.K. Safiq Ahmed, sir, Professor, IIT Indore and Organizing Secretary of this conference. Distinguished delegates, invited speakers, chairs, faculty colleagues, and research scholar students, ladies and gentlemen. Good afternoon to all of you. Today marks an important and fulfilling moment as we gather for the valedictory ceremony of the 4th International Conference on Recent Trends in Advanced Sciences and Land Computing, ICRTAC 2025. It is both a privilege and an emotional milestone for me as the convener to address you at the conclusion of this 3-day journey of knowledge exchange, reflection, and intellectual growth. A journey completed, a legacy continued. Over the past 3 days, we have witnessed inspiring keynote addresses, thought provoking technical sessions, breakthrough research presentations, cross disciplinary dialogue, meaningful academic network. What began as a platform to share research has grown into space where ideas converged, collaborations began, and foundations for future innovations were laid. We are deeply honored to conclude this event in the esteemed presence of Dr. S.K. Varshney, sir. Your distinguished career in the Department of Science and Technology and your contributions in advancing international scientific collaboration have significantly shaped India's global research relationship. Your presence today affirms the importance of conferences like ICRTAC 25 in driving forward the vision of a research focused, innovation driven nation. We express our deepest gratitude to our the Honorable Founder and Chancellor, Dr. G. Viswanath, whose vision, dedication, and unwavering commitment to quality education and research excellence have made VIT an institution of the international repute. We are equally grateful to Mr. Shankar Viswanathan, sir, Vice President, and Ms. Kadambari Viswanathan, Assistant Vice President, whose dynamic leadership, strategic guidance, and constant encouragement have shaped the growth of VIT Bhopal University. We convey our sincere thanks to Dr. T.B. Sridharan, Provost Vice Chancellor, for supporting academic and research culture and the successful execution of this conference. We extend our heartfelt appreciation to Mr. K.K. Nair, Registrar, for his support in functioning across all levels. We also express our sincere gratitude to Dr. Devashish Adhikari, sir, Dean Faculty Affairs, for strengthening the research and academic quality of the institutions, for providing quality of the institution, and for providing strategic guidance to our faculty members and research scholars. A very special thanks to Dr. Hemant Kumar Nashine, Professor and Dean SASL, and also I appreciate the organizing team. I will often place on record my sincere appreciation for the tremendous efforts of the organizing secretaries, Dr. Mamta Agarwal and Dr. S.K. Safiq Ahmed. I also extend my sincere thanks to Dr. Pushpendra Singh Kathija sir, Dean School, and their relentless hard work and meticulous planning, dedication, and leadership have contributed immensely to the success of ICRTASC 2025. So, the scientific depth, organizational excellence seen through this conference are a direct reflection of their commitment and vision. Thank you.
Thank you, Dr. Mukherjee, for your gracious welcome. And now, as our first formal gesture of honor, may I invite our organizing secretary, Dr. Mamta Agarwal ma'am, to present a bouquet to esteemed chief guest, Dr. S.K. Vashne sir, as a symbol of our deep respect and appreciation. Thank you, Dr. Agarwal, for that gracious gesture of welcome. To reflect upon the journey and success of this conference, it is now my privilege to invite Dr. Devashish Adhikari sir, our Dean of Faculty Affairs. We would be honored to hear your reflections on the accomplishments of ICRTASC 25. Welcome, sir.
Good afternoon, everyone. Dr. Varshini, Chief Guest, Dr. Ahmed from ID Indore, the entire School of SASL, Dr. Hemant Mashine, and other dignitaries present and the participants present. I would like to congratulate the entire School of SASL, especially the school dean and Dr. Mamta Agarwal and Dr. Yogesh Shukla and the entire team for the huge success of this fourth international conference on recent trends in advanced sciences and computing. The university would also like to express their gratitude to the funding agencies, SCRB and CSIR for their financial contribution, and of course, Dr. Ahmed of IIT Indore for his persistent support for this conference. I'm sure there would have been a lot of exchanges of ideas between the participants and the keynote speakers to make this conference a huge success. A lot of ideas might have transmitted on either side. I congratulate once again to the entire team for a hugely successful fourth ICR TASC conference. Thank you.
Thank you, sir, for your insightful reflections. We have now reached a moment of singular honor in our proceedings. It is with immense pleasure that I invite Dr. Pushpinder Singh Patija, sir, Dean of the School of Computing Science and Engineering, to come forward and felicitate our esteemed chief guest with a shawl and a memento as a token of appreciation. Thank you, Dr. Adhikari, sir, Dr. Patija, sir. for presiding over that gracious gesture of respect. The honor now continues as we prepare to welcome the distinguished leader who will illuminate our valedictory session. Dr. Pathija, we would be honored for you to introduce our esteemed chief guest. Please welcome, sir.
Thank you. Good afternoon, esteemed guests, distinguished speakers, respected fellow faculties, dear dignitaries, participants, and students. It is with immense pride and great pleasure that I introduce Dr. Sanjeev Kumar Bashne in the validatory function of 4th International Conference on Recent Trends in Advanced Science and Computing, ICR TASC 25. We are deeply honored to have on the dais today Dr. Sanjeev Kumar Bashne, sir, former head International Scientific Cooperation Ministry, Department of Science and Technology, Government of India. Dr. Sanjeev Kumar Bashne, sir, is a daily-based science facilitator and promoter. He has more than 33 years of experience promoting research and connecting scientific groups across the nation. Sir completed Master in Geology in 1984 from Aligarh Muslim University with university medals for obtaining first position. He qualified UGC NET in 1985 for Junior Research Fellowship and Leadership and Lectureship. He pursued research at University of Delhi during 1985 to 1990 on Himalayan river systems, sedimentation, seismic and tectonic modifications. He was also awarded Dr. D.N. Wadia Research Fellowship in 1986 for his research on Himalayan geology. He has been conferred Doctor of Science, DSc, honorary causa by Amity University, Rajasthan. Sir joined DST in year 1990 and had facilitated international scientific cooperation from the Department of Science and Technology with his bilateral, multilateral, and religion scientific partners. He was head of international scientific cooperation in Ministry, Department of Science and Technology, Government of India. Sir was the Indian co-chair governing body of the Binational Indo-German Science and Technology Center and the Binational US-India Science and Technology Endorsement Fund, both promoting joint industrial R&D, board of director of a private limited company, Global Innovation and Technology Alliance, and was member governing council of the International Advanced Research Center of Power Meteorology R&D lab of the SD Government of India. He was also the governing body member of the US Indian Education Foundation and the member board of research studies in Department of Geology, Aligarh Muslim University. He was representative of India to the International Center for Science and Technology Information, Moscow, during 2012 and 23. He was worked as counselor SNT with Embassy of India in Moscow. He has written several articles of science policies focusing on international scientific cooperation. His presence signifies the commitment of academic and industry leadership towards fostering technological growth and research excellence. Once again, I am pleased to welcome Dr. Bashne on this occasion. Thank you.
Thank you, Dr. Pathija, for that splendid introduction. Ladies and gentlemen, it is now my distinct pleasure to invite our chief guest, Dr. S.K. Vashne, to deliver the valedictory address. Sir, the stage is profoundly honored by your presence. We are all eager to hear your insights and wisdom.
Thank you. Namaskar.
Good afternoon. What a pleasant surprise for me to be here in VIT Vellore on my first visit. And I could see mark of the leader, Dr. Vishwanath. I have had a lot of interaction with him in Vellore, and I could see how he is passionate about the whole VIP culture and growing up and making more and more responsible citizens across the country. So my respects to Dr. Vishwanath. Equally, I would like to thank Shankar and Kadambari, the assistant, vice president and assistant vice president, university leadership, friends on the dais, Dr. Adhikari, Dr. Pushpender ji, Khateja ji, Dr. Shafiq Ahmed, Mamta ji, and Soni ji. Friends, there is a saying, all good thing comes to an end. So is this workshop. And valedictory session, I always feel, is not the end. It's end of an activity, but beginning of a newer activity. What are the takeaways we are taking from this workshop? That is the starting, a new starting point. And we need to see how we can help ourselves, our institutions, and our country through the route of science and technology. That is very important. And I was so excited when I was told it's an interdisciplinary discussions and people will come. No, unfortunately, in our system, I'm not saying about all countries, about India, our growth is subject vertical. Somebody read physics, somebody read mathematics, somebody reads chemistry, somebody biology, somebody mechanical, somebody electronic. And we feel that challenges faced by country could be answered by we alone. And that is a challenge. Now the time has come when research should help challenges being faced by the country and how we can do it. I'll just tell you some of the common challenge which interdisciplinary research could help. Country like India, we are going through two processes, urbanization and industrialization. And these two processes are happening at the cost of agricultural land and agriculture human resource. People are going to work in factory or cities, and every day one more village is demolished to be a part of concrete jungle. At the same time, our population is regularly increasing. And here is the scientific challenge. When number of mouths to be fed are increasing, agricultural land and agricultural human resources are decreasing. How do we feed our people in time to come? Only technology could provide solutions. And we need to look technology at every step. For example, the way we cultivate our crops. Currently, not currently, we should say, until some time ago, after sowing, we were irrigating our agricultural land by flooding. Whatever water is available, do it. Now time has changed. We are using a lot of sensors to see where the seeds are, how much water is required, in what quantity, at what time. Everything could be controlled. Similarly, when we are looking for newer technology, increase yield per hectare, or more nutrition in each crop, a lot of science is there. And then once crop is ready, India is one of those countries where there is criminal wastage of food from farm to home, it is still more than 33%, which is a criminal. Again, we require a lot of technologies to improve shelf life, to improve our technologies for transportation of crops, to repackage them in a condition where they could go for a long, survive, maintain taste, maintain nutritional value, those kind of. So this is just one challenge around food. But what I'm trying to say is not only biology. Now you combine it with the impact of climate change. Our weather cycle is not same, so we need to educate our farmers. See, the weather cycle is changed now. You need to shift when you are going to seed crop. So what I'm trying to say, challenge is one, but you will see interplay of lot of sciences. Each one can contribute in his or her own ways. Similarly, let us take about another challenge, healthcare. We are a country which has five-star hospitals where a lot of medical tourists are coming. But those hospitals are not good for our people. They can't afford it. We are looking for more affordable solutions. Government has insisted our doctors don't put branded medicine, insist on generic medicine. But you see, we need to work a lot on making new drugs. New formula is very expensive, but then we need to work. We need to provide medicines to everyone. I can just tell you the challenge. People who are living in far-flung area, even to get their blood test done, they need one full day. We can't rely they are living in city. We just go to doctor in 10 minutes we come out. But people who are living in remote area, inaccessible area, hilly area, they need to plan full day, and they are avoiding that. They are compromising with their health. They are deteriorating it further. We are insisting on now telemedicines. We are designing better solutions, and we are looking for it. And here comes a conflict. These days, everyone has got phone in hand. And phone is fortunately, unfortunately, full of AI drives. You put in a challenge, you put in a symptom, it will give you prognosis, it will give you diagnosis, it will tell you where to and when to die. Okay. Everything is possible. But remember, AI doesn't give you precise information what you are looking for. AI only provides you average of the available information in this system, which may or may not be good for you. These days, when we talk about healthcare, most of the AI tools are good for Western genes, not good for Indian genes. But these are there. Let's look at the Earth, a 5.8 billion year old system, where human beings we are there for last 10,000 years, and we have spoiled. We don't have air now to breathe. We don't have water. We have put all kind of discharge into the system. Question is how we are going to give it to our society. These days, there are marketing companies which have poisoned our market, poisoned our mind, that even water supplied by municipality, which is treated for all chemicals, all biological activities, even that we are processing at home. We will have either physical filter, RO, or some other filter system. It's marketing. Marketing has poisoned our minds. So we are not believing in our own system, but still treating, which is not required. Energy, another crisis. India is still an energy deficient country. We are looking for several solutions. We started with thermal energy, then we went for hydro energy, nuclear energy. But when we were going for nuclear energy, there were a lot of protests. And there have been accidents also, whether it is Fukushima or Chernobyl. And people have seen the disaster, how it could impact. So India cautiously did not expand nuclear energy program beyond a point. So we have nuclear energy, but we are not, had we allowed it, then probably we would have been energy surplus. Now we are looking for greener route, whether it is renewable energy. We are investing a lot on electric vehicles so that we could save. Idea is we need to be sustainable. India as a country has committed that all goals, sustainable development goal, we will abide by 2030, which is just 5 years from now, less than 5 years. No, just 5 years. And as far as emission is concerned, we have committed by 2070, we would be done away. We would be net zero by 2070. What I am trying to tell all you, there are a lot of challenges where interdisciplinary approach could help us in working out some of the challenges. And this is time for all the participants in this conference who have here. Please see how colleague working in some other discipline, but on this challenge where you are working and the other fellow is working, interests are common, that we could take it forward. And I'm very confident that partnership you will generate here would result in not only good quality publication, but would be a helping tool to improve our own living standards. Friends, if you talk of research funding agencies, these days more and more emphasis is given to problem thematic research problems, problem thematic research assignments. So some problem would be given and then you would be done. So you need to work out those things. And I think this platform like this workshop is ideal where you can nurture those dreams. You could find your partners and do it. So my good wishes to all of you. Make India strong by your research. Deliver some good quality research product, which could eventually be taken by the market and society. And I'm very confident you can do it. Thank you.
Thank you, sir, for that profoundly insightful and forward-looking address. Your words have not only elevated this gathering, but have also provided a clear vision to carry forward, challenging us to think bigger and reach further. To present a comprehensive account of a conference journey, it is now my pleasure to invite Dr. Dhiresh Soni. He will present the conference report of ICR-TASC 25. Dr. Dhiresh Soni, the floor is yours.
Good afternoon. Respected founder and chancellor VIT, Dr. G. Viswanathan sir, respected Vice President VIT Bhopal University, Mr. Shankar Viswanathan sir, respected Assistant Vice President Ms. Kadambari Viswanathan ma'am, Pro Vice Chancellor TV Sridharan sir, respected Registrar sir, Mr. K. K. Nair sir, and respected Dean Faculty of Dr. Devasish Adhikari sir, and respected Chief Guest S.K. Vasni sir, respected Professor and Dean, School of Advanced Science and Language, Dr. Hemant Kumar Nashin sir, and respected Professor and Dean from School of Computing Science, Dr. Pushpet Singh Pateja sir, respected Organization Secretary, Dr. Mamta Agarwal ma'am, and Dr. S.K. Safiq sir from IIT Indore. Good afternoon, everyone. Distinguished delegates, speakers, chairperson, then all the participants. Good afternoon to everyone. I'm Dr. Dinesh Soni, convener of the this conference. So I'm here to present the report, 3-day report for the conference. So ICRTSC 2025 started with the 17th November to 19th November, and this conference was held by a School of Science, sorry, School of Advanced Science and Languages, with the collaboration of IIT Law. Now here I'm going to represent the report. We started with the day one on the 17th November. We are started with the plenary keynote and lectures. So in the day one, we have a three plenary lectures. It is delivered by Professor Imtian from Indonesia, Professor Atul Gaur from University of Delhi, Professor Sakir Ali from Aligarh Muslim University, and three keynote lecture delivered by Dr. Ratikant Bera from IISc Bangalore, Professor Dr. Dharavat Ramesh from IIT ISM Dhanbad, Professor Kailash Yadav, Central University of Haryana. And this next that we have a technical session. We have a two sessions. Session one that is offline. Session two that is online. So in the offline session, this was session chaired by Professor Manisha Jain and Professor Sakir Ali. In this, we have presented 11 papers or as offline. In session two, which is online, that session is chaired by Zahir Karim Ansari and Anand Khan Shukla sir, where we total six papers is presented online in the day one. So for the small day one summary, total keynote lecture is three, plenary lecture is three, and total paper presented is 17, out of which six is the online and 11 are the offline. For the day two, again we started with the same. We have a plenary and keynote lecture. In the day two, we have a two plenary lecture that is delivered by Professor K.F. Pawar and Patrick Stanovarik from Serbia. Then we have a keynote lecture for day two. We have a total five keynote lecture that was delivered by first Professor Dedanti Kesri Sahu from BIST Goa. Then we have a Professor M. Tanveer from IIT Indore. Then we have a Bappan Bhoshar from IIT Indore, Professor Akhil Khan sir, and last was the Professor Bhupen Pathak sir from JUIT. And for the technical session part, again for the offline session, we have the session is shared by Professor M. Tanveer and Professor K.F. Pawar, where 10 participants have presented their paper in offline mode. Now for the session two, that is online mode, here the session is shared by Professor Reena Jain and Professor Navneet Verma sir. And the second session, we have a 9 online presentation. So entire summary for the day two, we have plenary lectures two, and keynote lectures we have 5, and total paper presented is 19, out of which 9 is online and remaining 10 is offline. For the day three, we have a total plenary lecture is 1, that is delivered by Professor Yelis Karasa from USA. For keynote lecture, we have a 6 keynote lecture. The first started with the Manoj Patel sir from NIT Nagaland. Then we have Professor Ismail A. Magid from UK. Then we have a Siva Kumar from IIT Madras, Professor Jitu Parnav Goswami, and followed by Krishna Bhagwan from UK. And last is the Professor Adrian Marin, that is given online. Now, in the technical session, in the session one, so we have total 8 papers was presented in the session first. The session is chaired by Professor Manoj Patel sir and Dr. Ajay Burji. In the second session, that is online, it was session by Professor Deepak Srivastav and Professor Firoz Babu. Here, 8 paper is presented online. For the entire small summary for day 3, total number of keynote lectures is 6, plenary lectures is 1, and number of paper presented is 16, out of which 8 is online and 8 is offline. So overall conference summary, I'm going to describe one more time for the 3 days. The conference start from 17 to 19. In these 3 days, total we have 6 plenary lectures and 15 keynote lectures, and total number of presented is 52, out of which 23 is online and 29 is offline. Thank you.
Thank you, Dr. Soni, for that comprehensive and encouraging report. To bring our conference experiences into full perspective, it is now my distinct honor to invite our organizing secretary, Dr. Shafiq Ahmed sir, from IIT Indore, to present the conference summary. Sir, we would be privileged to hear your reflections on the intellectual journey we have shared these past 3 days.
Thank you very much, each and everyone. Chief guest, Dr. Vasu, and Deans, Dr. Devashish, Dr. Hemant, and Dr. Pushpendra, and Dr. Mamta, and the Vice Chancellor of this university, and the Chancellor of this university. Actually, this conference, it is a unique conference, I can say. And here we gathered together various areas people, including pure and applied, computing, computational, and the engineering aspects, things we have discussed. So here, one thing I have observed during this conference that our keynote speaker and the plenary speakers, they are from diverse area. They are working in pure and also they are doing computational aspects as well and doing computing as well. Here, computational means it is not like that just we are doing competitions. The competition means how we look our problem. There are different kinds of problem. One is ill-posed problem and one is well-posed problem. The well-posed problem, it is easy to solve. There is a technique and there is a procedure, there is an algorithm, and just put your result and you get your answer and you show the graph the different ways. But there are problems, they are very sensitive, they are very ill conditioned, they are very, very means, scientific. And those results it is helpful for the further research for the development of our country and the development of our different aspects where we are lagging behind. Say, for example, I can give you here the traffic system of India. That is one part of the research we have not yet started. And that we just speak in our conference or give talk a lot of things, but in real sense, it is not coming up in the platform. Okay, that part is missing. So I remember when I went to Berlin, Germany, I was working on linear algebra, and my professor told that, okay, your work is applying in car designing. Well, what? I don't know anything about car designing. Eigenvalue problems, he would be helping to minimize the vibration of the rail, minimizing the vibration of the car, and all the sophisticated things can be developed by one technology, whatever we are doing research, but we don't know at all. But we speak a lot. Whenever stage comes, we speak, we can do a lot of things. It is not like that publishing paper. We publish a lot of papers, but in the real sense, what is the impact of those papers? That should be acknowledged. And now I can say frankly that in university, in various places, it depends your promotion based on your number of papers. And that should not be at all the criteria for the number of papers for the promotion of that particular faculty. So what we should make the things in such a way that in future we can see our India in the developed nation because we are developing a country. I remember I was in Germany. I missed my passport. Okay, my professor told that okay, you go and keep some money to Indian embassy within the 15 hours you can get it. And at the end you told her, don't do that. Don't do that at all. So anyway, I took a lot of time to get my passports. So that was our the work procedure. So here I would like to say all the participants, especially the speakers from the different areas, say, in the fractals, we have seen many applications here. Majid, Professor Majid from UK has given a lot of application. People are working the fractal here also, but they don't know where is the applications. They just tell that, okay, we are pure analysis people, we don't know applications. That should not be part of that one. We should know what is the application. Even if we are developing theoretical version, that doesn't matter. But at least we should know where we are going to use that kind of application. Here I've seen, say, the group of Professor Sakir Ali and this Imtaz and this Elise, and they have given the very nice talk. And I think our participants be getting that benefit to see for their further research. And one more thing, wherever we are conducting in the say VIT, this is the platform, and our main focus is this university should get benefit much. And their participants from this undergraduates, uh, I know they are busy in exam and they are busy in various courses, and the faculty are busy, but at least we should expect 20% or 10% their community should be present over here. At least they can acknowledge, they can say that, okay, this kind of conference we have organized in this institute, and students should get benefit. So I'd like to thank all the organizing team, convener and the co-convener, and Professor Mamta for day and night work to make this conference successful. And entire team, I can say the administration of VIT Bhopal and each and every one of this institute, especially those who are involved to make this conference successful. So thank you all. I hope you will get benefit with this conference. Thank you so much.
Thank you, Dr. Ahmed, for that comprehensive summary, which so perfectly captures both the achievements and the collaborative spirit of our conference. Now we would like to call our chairman of the conference and dean of SASL, Dr. Hemant Kumar Nashi, to facilitate our collaborator, Dr. S.K. Shafiq Ahmed sir from IIT Indore, with a token of appreciation and a memento. Thank you, sir. Now I would like to call our organizing secretary, Dr. Mamta Agarwal, to present a memento to our hardworking volunteers who made this conference possible. The names are Krida, Shivendra, Archie, Ujjwal, Harshit, Jayesh. Kindly come on the stage and others later. Volunteers kindly come on the stage. Krida, Shivendra, Ashi, Ujjwal, Harshit, and Jayesh. These students work really hard day and night to make this conference successful.
Motion is there? Motion. Which come first? Even later. Sir, we consider but he completely day and night. Oh, exactly. It's very just.
Can you show your audio on the
Much. Shine my skill. He can start.
Ceremony, it is time to express a profound gratitude to the many individuals whose dedication and hard work make this conference possible. It is now my privilege to invite Dr. Adnan Abbasi sir to deliver the vote of thanks, acknowledging all those who contributed to the success of ICRTASC 25. The stage is yours, sir.
distinguished dignitaries, esteemed chief guests, learned professors, dynamic researchers, and the vibrant students community of VIT Bhopal. Good afternoon. As the sun begins to the set on the fourth International Conference on Recent Trends in Advanced Sciences and Computing, I find myself reflecting not just on the last 3 days, but on the journey that brought us here. We gathered here under the aegis of the School of Advanced Sciences and Languages in prestigious collaboration with IIT Indore, driven by the ambitious theme often we treat science and computing as the separate soils, science as the theory and the computing as the tool. But if ICRTAC 225 has taught us anything, it is that is this distinct the vanishing from the discussion of sciences and computing, we have that today science is the architect and computing is the builder. Gratitude is the memory of the heart, and my heart is full today. No event of this scale happens in isolation. It is a symphony composed by many hands. It is my privilege to formally propose the vote of thanks. First, we bow the gratitude to the visionary leadership that makes VIT a beacon of excellence. Our deepest thanks to our chief guest, Honorable Dr. G. Viswanathan, founder and chancellor of VIT University. His relentless pursuit of quality education is the wind beneath our wings. We are equally indebted to our patrons, Mr. Shankar Viswanathan and Ms. Kadamni S. Viswanathan. Thank you for your unwavering trust and support. We are immense honored to have had Dr. S.K. Vaishnav with us as our chief guest. Sir, your presence and insight have the elevated our statures of this conference and inspired every researcher present here. Thank you very much for your time and wisdom. A special note of thanks to our co-patrons and VIT Bhopal who smoothed every bump in the road. Professor T.B. Shidran, our Pro Vice Chancellor of his academic mentorship. Mr. K. Nair, our acting registrar. Dr. Debashish Adhikari, Dean of Faculty Affairs. Thank you of facilitating to environment that made this conference possible. Great things are never done alone. We are profoundly grateful to the Indian Institute of Technology, IIT Indore. Your collaboration brought a rigorous academic stand to this forum. A special mention to the Professor Shafiq Ahmed from IIT Indore, who stood shoulder to shoulder with us, and a special thanks to our senior and organizing secretary, Dr. Mamta Agarwal ma'am, for her motivation, support, and guidance. To the captain of this ship, our dean, sir, Professor Hemant Kumar Nahini, sir, you are meticulous planning and calm leadership turned a complex vision into the seamless reality. To my fellow convener, Dr. Deep Mukherjee and Dr. Krish Soni, and our tireless
co-convener Dr. Yogesh Shukla and Dr. Ajay Sharma, sir, we have shared hundreds of emails and sleepless nights, and together seeing this success, it was all worth it. We must acknowledge to the local advisory, scientific advisory, and technical committee for ensuring every paper were reviewed with integrity. A loud round of applause, please, for our technical support team, administrative staff, and our brilliant student volunteers. Astha, Shivendra, Ashi, Ujjwal, and Prashita, and their entire teams. You run the registration desk, manage the hybrid session, and solve problems before we ever knew they exist. You are the unsung heroes of ICRTAC 25. Finally, to you, the delegates, you traveled from different states and different time zones to be here. Your questions, your curiosity, and your presence turned this from a meeting into the community. We wish you a safe journey back to your home and institution. We eagerly await welcoming you back to the next edition. Thank you all. Jai Hind.
Thank you, Dr. Basil, for those heartfelt words of appreciation. Now I would call everyone for a group photograph. Kindly everyone present on the stage.
फोटो खिंचाने का तू पीछे का खिंचवाऊंगा मैं तो वही तो खींचूंगा आजा तू भी आजा
All the professors, please come on the stage, and all the volunteers stay in front of the stage for the group photograph. All the professors on the stage. All the volunteers kindly assemble in front of the stage. Yes.
सर ये सर्टिफिकेट को डिस्ट्रीब्यूट करेंगे तो ऑनलाइन शेयर कर देंगे सर्टिफिकेट और सभी को ऑनलाइन ही शेयर कर देंगे मतलब सचिन वाला ऑनलाइन शेयर कर देंगे और ऑफलाइन वाला मोस्टली दे दिया तो एंड लेट हिम दिस वीक वन राजा पेंडू राजू तरीका लगा राजू जी बेटा
फोटोग्राफर आजा स्क्रीन आ जाए हाँ क्लियर आना चाहिए स्क्रीन I think
Now we formally bring the fourth international conference on recent trends in advanced science and computing to a close. On behalf of the entire organizing committee, I extend our deepest appreciation to our distinguished chief guest, our respected Dean of Faculty Affairs, all our esteemed dignitaries, deans of various schools, session speakers, faculty members, and support staff for invaluable contributions in making this conference a resounding success. Now we will go for high tea in the mini auditorium. I request all the faculties and the volunteers to go for high tea in the mini auditorium. Thank you for being an essential part of this remarkable journey. The conference is now officially concluded. Wishing you a all the volunteers kindly stay in the auditorium only. All the volunteers don't go for high tea. Stay in the auditorium only.
Please stay in the auditorium only.